1. Introduction to Python. 1.1 What is Python? Python is a high-level, interpreted programming language that was created by Guido van Rossum and first released in 1991. It is known for its simplicity and readability, making it an excellent choice for beginners who are just starting to learn programming. Python is widely used in various domains, including web development, data analysis, artificial intelligence, scientific computing, and more. Python is an open-source language, which means that its source code is freely available and can be modified and distributed by anyone. This has contributed to its popularity and has led to a large and active community of developers who continuously contribute to its growth and improvement. One of the key features of Python is its emphasis on code readability. The language uses a clean and straightforward syntax that is easy to understand, even for those who are new to programming. Python code is typically written in a way that resembles plain English, making it more intuitive and less prone to errors. Python is an interpreted language, which means that it does not need to be compiled before it can be executed. Instead, the Python interpreter reads and executes the code line by line, making it easier to write and test code quickly. This also allows for a more interactive programming experience, as developers can experiment with code snippets and see the results immediately. Python is a versatile language that supports multiple programming paradigms, including procedural, object-oriented, and functional programming. This flexibility allows developers to choose the most suitable approach for their projects and enables them to write code that is both efficient and maintainable. Another advantage of Python is its extensive standard library, which provides a wide range of modules and functions that can be used to perform various tasks. The standard library includes modules for working with files, handling network communication, processing data, and much more. This eliminates the need to reinvent the wheel and allows developers to focus on solving the specific problems they are working on. In addition to the standard library, Python has a vast ecosystem of third-party libraries and frameworks that further extend its capabilities. These libraries cover a wide range of domains, including web development e.g., Django, Flask data analysis e.g., NumPy, Pandas machine learning e.g., TensorFlow, PyTorch, and more. The availability of these libraries makes Python a powerful tool for tackling complex projects and enables developers to leverage existing solutions and resources. Python is a cross-platform language, which means that it can run on various operating systems, including Windows, macOS, and Linux. This allows developers to write code once and run it on different platforms without making significant modifications. Python's cross-platform compatibility makes it an excellent choice for developing applications that need to be deployed on multiple systems. Overall, Python is a versatile and beginner-friendly programming language that offers a wide range of features and capabilities. Its simplicity, readability, and extensive ecosystem make it an excellent choice for both beginners and experienced developers alike. Whether you are interested in web development, data analysis, artificial intelligence, or any other field, Python provides the tools and resources you need to bring your ideas to life. 1.2 Installing Python. Before you can start programming with Python, you need to install it on your computer. Python is a free and open-source programming language, which means you can download and install it without any cost. In this section, we will guide you through the process of installing Python on different operating systems. Installing Python on Windows. To install Python on Windows, follow these steps. Visit the official Python website at. Click on the Downloads tab at the top of the page. Scroll down to the section titled Python Releases for Windows, and click on the link for the latest version of Python. On the download page, you will see two options, Python 3, X, and Python 2, X. It is recommended to choose Python 3, X as it is the latest stable version. Click on the Windows x86 64 executable installer link if you have a 64-bit version of Windows, or the Windows x86 executable installer link if you have a 32-bit version of Windows. Once the installer is downloaded, double-click on it to start the installation process. In the installer, make sure to check the box that says, Add Python to Path, and then click on the Install Now button. The installer will now install Python on your computer. This may take a few minutes. Once the installation is complete, you can close the installer. To verify that Python is installed correctly, open the command prompt and type Python version. You should see the version number of Python that you installed. Installing Python on macOS. To install Python on macOS, follow these steps. Open a web browser and go to the official Python website at. Click on the Downloads tab at the top of the page. Scroll down to the section titled Python Releases for macOS, and click on the link for the latest version of Python. On the download page, you will see two options, Python 3, X and Python 2, X. It is recommended to choose Python 3, X as it is the latest stable version. Click on the macOS 64-bit installer link to download the installer. Once the installer is downloaded, double-click on it to start the installation process. In the installer, follow the on-screen instructions and click on the Install button. The installer will now install Python on your computer. This may take a few minutes. Once the installation is complete, you can close the installer. To verify that Python is installed correctly, open the terminal and type Python 3 version. You should see the version number of Python that you installed. Installing Python on Linux. Python is usually pre-installed on most Linux distributions. However, if it is not installed or you want to install a specific version, you can use the package manager for your distribution to install Python. For example, on Ubuntu or Debian-based distributions, you can use the following command to install Python 3. sudo apt-get update sudo apt-get install Python 3. On Fedora or CentOS-based distributions, you can use the following command to install Python 3. sudo dnf install Python 3. To verify that Python is installed correctly, open the terminal and type Python 3 version. You should see the version number of Python that you installed. Choosing an integrated development environment (IDE). After installing Python, you can start writing and running Python programs. However, using an integrated development environment (IDE) can greatly enhance your programming experience. An IDE provides features like code completion, debugging tools, and project management. There are several popular Python IDEs available, including PyCharm, a powerful and feature-rich IDE developed by JetBrains. Visual Studio Code, a lightweight and customizable IDE developed by Microsoft. IDLE, the default IDE that comes with Python. Jupyter Notebook, an interactive web-based IDE for data analysis and visualization. You can choose any IDE that suits your needs and preferences. In this book, we will use Visual Studio Code as the recommended IDE, but you are free to use any IDE you are comfortable with. To install an IDE, simply visit the official website of the IDE you want to use and follow the installation instructions provided. Congratulations! You have successfully installed Python on your computer and are ready to start programming. In the next section, we will learn how to run Python programs. 1.3 Running Python Programs. Once you have installed Python on your computer, you are ready to start running Python programs. In this section, we will explore different ways to run Python programs and execute your code. Running Python from the command line. One of the simplest ways to run Python programs is by using the command line. The command line interface allows you to interact with your computer's operating system directly. To run a Python program from the command line, follow these steps. Open the command prompt or terminal on your computer. Navigate to the directory where your Python program is located using the cd command. For example, if your program is in a folder called my_programs, on your desktop, you would use the command cd desktop my_programs. Once you are in the correct directory, you can run your Python program by typing Python followed by the name of your program file. For example, if your program file is called my_program.py, you would type Python my_program.py and press enter. The Python interpreter will then execute your program, and you will see the output displayed in the command prompt or terminal. Running Python in an integrated development environment (IDE). An integrated development environment (IDE) is a software application that provides comprehensive tools and features for writing, testing, and debugging code. IDEs are popular among developers as they offer a more user-friendly and efficient way to write and run code. Here are a few popular Python IDEs. PyCharm. PyCharm is a powerful IDE developed by JetBrains. It offers a wide range of features such as code completion, debugging tools, and version control integration. PyCharm is available in both free and paid versions. Visual Studio Code. Visual Studio Code (VS Code) is a lightweight and versatile code editor developed by Microsoft. It supports various programming languages, including Python, and offers extensions for additional functionality. VS Code is free and highly customizable. Spyder. Spyder is an open-source IDE specifically designed for scientific computing and data analysis. It provides a MATLAB-like interface and integrates with popular scientific libraries such as NumPy and Pandas. Spyder is free and easy to use. To run a Python program in an IDE, follow these general steps. Open your preferred IDE and create a new Python file or open an existing one. Write your Python code in the editor window. Save the file with a .py extension. Use the IDE's built-in tools or keyboard shortcuts to run the program. This may involve clicking a Run button, selecting a menu option, or pressing a specific key combination. The IDE will then execute your program and display the output in a designated output window or console. Running Python in Jupyter Notebooks. Jupyter Notebooks provide an interactive computing environment that allows you to create and share documents containing live code, visualizations, and explanatory text. Jupyter Notebooks are widely used in data science and research communities. To run Python code in a Jupyter Notebook, follow these steps. Install Jupyter Notebook on your computer by running the command pip install Jupyter in your command prompt or terminal. Open the command prompt or terminal and navigate to the directory where you want to create your Jupyter Notebook. Type Jupyter Notebook and press enter. This will start the Jupyter Notebook server and open a new tab in your web browser. In the Jupyter Notebook interface, click on New, and select Python 3 inches to create a new notebook. In the notebook, you can write your Python code in individual cells. Press Shift plus Enter to run a cell and move to the next one. The output of each cell will be displayed below it. Jupyter Notebooks allow you to mix code, text, and visualizations in a single document, making it a powerful tool for data analysis and exploration. Running Python online. If you don't have Python installed on your computer or prefer not to install it, you can also run Python programs online using various web-based platforms. These platforms provide a virtual environment where you can write and execute Python code without the need for local installation. Some popular online Python platforms include REPL.IT. REPL.IT is an online coding platform that supports multiple programming languages, including Python. It provides a simple and intuitive interface for writing and running code in your web browser. Google Colab. Google Colab is a cloud-based Jupyter Notebook environment provided by Google. It allows you to create and run Jupyter Notebooks directly in your web browser. Google Colab also provides access to powerful hardware resources for running computationally intensive tasks. Python Anywhere. Python Anywhere is a web-based Python development and hosting platform. It offers an integrated development environment, allowing you to write, run, and host Python applications entirely online. These online platforms are convenient for quick prototyping, learning Python, or collaborating with others without the need for local installation. In this section, we explored different ways to run Python programs, including using the command line, IDEs, Jupyter Notebooks, and online platforms. Choose the method that suits your needs and preferences, and start executing your Python code with confidence. 1.4 Python Development Environments. Python is a versatile and powerful programming language that can be used for a wide range of applications. To write and run Python code, you need a development environment. A development environment is a software tool or platform that provides the necessary tools and features to write, test, and debug code efficiently. In this section, we will explore some popular Python development environments and discuss their features, advantages, and disadvantages. Whether you are a beginner or an experienced programmer, choosing the right development environment can greatly enhance your productivity and coding experience. 1. Integrated Development Environments (IDEs). Integrated Development Environments (IDEs) are comprehensive software applications that provide a complete set of tools for software development. IDEs are designed to streamline the coding process by offering features such as code editors, debuggers, code completion, and project management tools. 1.1 PyCharm. PyCharm is a popular Python IDE developed by JetBrains. It offers a wide range of features that make it a favorite among Python developers. PyCharm provides intelligent code completion, code navigation, and refactoring tools, which help in writing clean and error-free code. It also has a built-in debugger that allows you to step through your code and identify and fix any issues. 1.2 Visual Studio Code. Visual Studio Code (VS Code) is a lightweight and versatile code editor developed by Microsoft. Although it is not a full-fledged IDE, it offers a rich set of features and extensions that make it a powerful tool for Python development. VS Code provides a user-friendly interface, integrated terminal, and support for version control systems. It also has a vast library of extensions that can be used to customize and enhance its functionality. 1.3 PyDev. PyDev is an open-source Python IDE that is built on top of the Eclipse platform. It provides a feature-rich environment for Python development, including code completion, debugging, and refactoring tools. PyDev also offers integration with popular version control systems and supports the development of Django and Google App Engine applications. 2. Text editors. Text editors are lightweight software applications that are primarily designed for editing plain text files. While they may not offer the same level of features and functionality as IDEs, text editors are simple and efficient tools for writing Python code. 2.1 Sublime Text. Sublime Text is a popular text editor known for its speed and simplicity. It offers a clean and intuitive interface and supports a wide range of programming languages, including Python. Sublime Text provides features like syntax highlighting, code folding, and multiple cursors, which can greatly improve your coding experience. 2.2 Atom. Atom is an open-source text editor developed by GitHub. It is highly customizable and offers a wide range of features through its extensive library of packages and themes. Atom provides a user-friendly interface, integrated Git support, and a built-in package manager. With the right packages, Atom can be transformed into a powerful Python development environment. 2.3 Notepad++. Notepad++ is a free and lightweight text editor for Windows. It offers a simple and intuitive interface and supports syntax highlighting for various programming languages, including Python. Notepad++ provides features like search and replace, code folding, and macro recording, which can be useful for writing and editing Python code. 3. Online Development Environments. Online development environments are web-based platforms that allow you to write, run, and share code without the need for any local installation. These environments are particularly useful if you want to quickly test and experiment with Python code without setting up a local development environment. 3.1 Replit. Replit is an online coding platform that supports multiple programming languages, including Python. It provides a simple and intuitive interface and allows you to write, run, and share code directly from your web browser. Replit offers features like code completion, collaboration tools, and integration with version control systems. 3.2 Google Colab. Google Colab is a cloud-based Python development environment that is powered by Jupyter Notebooks. It allows you to write and execute Python code in a browser-based interface. Google Colab provides access to powerful hardware resources and supports the use of GPUs and TPUs for accelerated computing. It also offers integration with Google Drive, allowing you to easily save and share your notebooks. Conclusion. Choosing the right Python development environment is essential for efficient and productive coding. Whether you prefer the comprehensive features of an IDE, the simplicity of a text editor, or the convenience of an online platform, there are plenty of options available to suit your needs. Experiment with different environments and find the one that best fits your coding style and workflow. Remember, the development environment you choose should empower you to write clean, maintainable, and error-free Python code. 2. Python Basics. 2.1 Variables and Data Types. In Python, variables are used to store data values. A variable is like a container that holds a value, and it can be assigned a name so that we can refer to it later in our code. Python is a dynamically typed language, which means that we don't need to explicitly declare the type of a variable. The type of a variable is determined based on the value assigned to it. Variable naming rules. Before we dive into the different data types in Python, let's first understand the rules for naming variables. In Python, variable names must start with a letter or an underscore, can only contain letters, numbers, and underscores cannot be a reserved keyword e.g., if, for, while, etc. Or case-sensitive e.g., my variable, and, my variable, are different. It is good practice to choose meaningful and descriptive names for your variables to make your code more readable and maintainable. For example, instead of using a variable name like x, you can use age to represent a person's age. Data types. Python has several built-in data types that are used to represent different kinds of values. Let's explore some of the commonly used data types in Python. Numeric types. Python supports various numeric types, including integers, floating point numbers, and complex numbers. Integers. Integers are whole numbers without any decimal point. For example, 5, -10, and 0 are integers in Python. Floating point numbers. Floating point numbers, also known as floats, are numbers with a decimal point. For example, 3.14, -2.5, and 0.0 are floats in Python. Complex numbers. Complex numbers are numbers with a real and imaginary part. They are represented as a plus bj, where a is the real part and b is the imaginary part. For example, 2 plus 3j is a complex number in Python. Strings. Strings are used to represent text data in Python. They are enclosed in either single quotes or double quotes. For example, hello, world, and Python are strings in Python. Strings can be concatenated using the plus operator and can be accessed using indexing and slicing. Booleans. Booleans represent the truth values true and false. They are used in logical operations and control flow statements. For example, in an if statement, the condition is evaluated to either true or false, and the corresponding block of code is executed based on the result. Lists. Lists are used to store a collection of items in Python. They are ordered and mutable, which means that you can change, add, or remove items from a list. Lists can contain elements of different data types. To define a list, you enclose the items in square brackets separated by commas. For example, 1, 2, 3, and apple, banana, orange are lists in Python. Tuples. Tuples are similar to lists, but they are immutable, which means that you cannot change the elements once they are assigned. Tuples are defined by enclosing the items in parentheses separated by commas. For example, 1, 2, 3, and apple, banana, orange are tuples in Python. Dictionaries. Dictionaries are used to store key-value pairs in Python. Each value is associated with a unique key, which can be used to retrieve the value later. Dictionaries are defined by enclosing the key-value pairs in curly braces and separating them with colons, smiley face. For example, name, John, age, 25 is a dictionary in Python. Sets. Sets are used to store a collection of unique elements in Python. They are unordered and mutable. Sets are defined by enclosing the elements in curly braces or by using the set function. For example, 1, 2, 3 and set 1, 2, 3 are sets in Python. Type conversion. Python provides built-in functions to convert values from one data type to another. This process is known as type conversion or typecasting. Some commonly used type conversion functions include int, float, str, and list. For example, you can convert an integer to a string using the str function. In this section, we learned about variables and different data types in Python. Understanding data types is essential as it helps us work with different kinds of values and perform operations accordingly. In the next section, we will explore operators in Python, which allow us to perform various computations and manipulations on our data. 2.2 Operators. In Python, operators are symbols or special characters that perform specific operations on one or more operands. They allow you to manipulate and perform calculations on variables and values. Python provides a wide range of operators that can be classified into different categories, such as arithmetic operators, assignment operators, comparison operators, logical operators, and more. In this section, we will explore these different types of operators and learn how to use them effectively in Python. Arithmetic operators. Arithmetic operators are used to perform mathematical calculations on numeric values. Python supports the following arithmetic operators. Addition plus adds two operands. Subtraction subtracts the second operand from the first operand. Multiplication asterisk multiplies two operands. Division divides the first operand by the second operand. Modulus percent returns the remainder of the division between the first operand and the second operand. Exponentiation asterisk asterisk raises the first operand to the power of the second operand. Floor division returns the quotient of the division between the first operand and the second operand, discarding any remainder. Here's an example that demonstrates the use of arithmetic operators. X equals 10, y equals 3. Addition equals x plus y, subtraction equals x, y multiplication equals x, y division equals x, y modulus equals x percent, y exponentiation equals x asterisk asterisk y floor underscore division equals x, y. Print addition hash output. 13 print subtraction hash output. 7 print multiplication hash output. 30 print division hash output. 3.33333333333333335 print modulus hash output. 1 print exponentiation hash output. 1000 print floor underscore division hash output. 3 assignment operators. Assignment operators are used to assign values to variables. They combine the assignment smiley face operator with other arithmetic or logical operators to perform an operation and assign the result to a variable. Here are some commonly used assignment operators in Python. Equals assigns the value on the right to the variable on the left. Plus equals adds the value on the right to the variable on the left and assigns the result to the variable on the left. Equals subtracts the value on the right from the variable on the left and assigns the result to the variable on the left. Asterisk equals multiplies the variable on the left by the value on the right and assigns the result to the variable on the left. Equals divides the variable on the left by the value on the right and assigns the result to the variable on the left. Percent equals performs modulus operation on the variable on the left with the value on the right and assigns the result to the variable on the left. Equals raises the variable on the left to the power of the value on the right and assigns the result to the variable on the left. Equals performs floor division on the variable on the left with the value on the right and assigns the result to the variable on the left. Here's an example that demonstrates the use of assignment operators. X equals 10. X plus equals 5 hash equivalent to x equals x plus 5 print x hash output 15. X equals 3 hash equivalent to x equals x3 print x hash output 12. X asterisk equals 2 hash equivalent to x equals x asterisk 2 print x hash output 24. X equals 4 hash equivalent to x equals x 4 print x hash output 6.0. X percent equals 5 hash equivalent to x equals x percent 5 print x hash output 1.0. X asterisk asterisk equals 3 hash equivalent to x equals x asterisk asterisk 3 print x hash output 1.0. X equals 2 hash equivalent to x equals x 2 print x hash output 0.0. Comparison operators. Comparison operators are used to compare two values and return a Boolean value, true or false, based on the comparison result. Python supports the following comparison operators. Equals equals checks if the values of two operands are equal. Exclamation mark equals checks if the values of two operands are not equal. Less than checks if the value of the left operand is less than the value of the right operand. Checks if the value of the left operand is greater than the value of the right operand. Less than equals checks if the value of the left operand is less than or equal to the value of the right operand. Equals checks if the value of the left operand is greater than or equal to the value of the right operand. Here's an example that demonstrates the use of comparison operators. X equals 5, y equals 10. Print x equals y hash output false print x equals y hash output true print x less than y hash output true print x greater than y hash output false print x less than equals y hash output true print x greater than equals y hash output false. Logical operators. Logical operators are used to combine multiple conditions and perform logical operations. Python supports the following logical operators. AND returns true if both conditions are true. OR returns true if at least one of the conditions is true. NOT returns the opposite of the condition. Here's an example that demonstrates the use of logical operators. X equals 5, y equals 10. Print x greater than 0 and y less than 20 hash output. True print x greater than 0 or y less than 20 hash output. True print not x greater than O hash output false. These are just a few examples of the operators available in Python. Understanding and mastering these operators is essential for writing effective and efficient Python code. By using operators effectively, you can perform complex calculations, make decisions based on conditions, and manipulate data with ease. 2.3 Control flow. Control flow refers to the order in which statements are executed in a program. In Python, control flow is managed through various control structures such as conditional statements and loops. These structures allow you to make decisions and repeat certain blocks of code based on specific conditions. Understanding control flow is essential for writing efficient and effective programs. Conditional statements. Conditional statements allow you to execute different blocks of code based on certain conditions. The most commonly used conditional statement in Python is the if statement. The syntax of an if statement is as follows. If condition. Hash code to be executed if the condition is true. The condition is an expression that evaluates to either true or false. If the condition is true, the code block indented under the if statement is executed. If the condition is false, the code block is skipped. You can also include an else statement to specify a block of code to be executed if the condition is false. The syntax for an if-else statement is as follows. If condition. Hash code to be executed if the condition is true else. Hash code to be executed if the condition is false. In addition to if-else statements, you can also use elif statements to specify multiple conditions. The syntax for an if-else statement is as follows. If condition 1. Hash code to be executed if condition 1 is true elif condition 2. Hash code to be executed if condition 2 is true else. Hash code to be executed if all conditions are false. The elif statement allows you to check additional conditions if the previous conditions are false. You can have multiple elif statements to check for different conditions. Loops. Loops allow you to repeat a block of code multiple times. Python provides two types of loops, for loops and while loops. For loops. A for loop is used to iterate over a sequence of elements such as a list, tuple, or string. The syntax of a for loop is as follows. For element in sequence. Hash code to be executed for each element. The element variable takes on the value of each element in the sequence, one at a time. The code block indented under the for loop is executed for each element in the sequence. You can also use the range function to generate a sequence of numbers to iterate over. The range function takes three arguments, start, stop, and step. The start argument specifies the starting value of the sequence default as 0, the stop argument specifies the ending value, not inclusive, and the step argument specifies the increment default as 1. For I in ranged start, stop, step. Hash code to be executed for each value of I while loops. A while loop is used to repeat a block of code as long as a certain condition is true. The syntax of a while loop is as follows. While condition. Hash code to be executed as long as the condition is true. The condition is an expression that is evaluated before each iteration of the loop. If the condition is true, the code block indented under the while loop is executed. If the condition is false, the loop is exited and the program continues with the next statement after the loop. It is important to ensure that the condition in a while loop eventually becomes false to avoid an infinite loop. You can use control statements such as break and continue to control the flow of a loop. Control statements. Control statements allow you to alter the flow of a loop or conditional statement. The two most commonly used control statements in Python are break and continue. The break statement is used to exit a loop prematurely. When the break statement is encountered, the loop is immediately terminated, and the program continues with the next statement after the loop. For element in sequence. If condition, break. Hash code to be executed for each element. The continue statement is used to skip the rest of the code block in a loop and move on to the next iteration. When the continue statement is encountered, the program jumps to the next iteration of the loop without executing the remaining code in the current iteration. For element in sequence. If condition, continue. Hash code to be executed for each element. Both break and continue statements can be used with both for and while loops. Conclusion. Control flow is an essential concept in programming as it allows you to make decisions and repeat code based on specific conditions. Conditional statements such as if else, and if else allow you to execute different blocks of code based on conditions. Loops such as for and while allow you to repeat code multiple times. Control statements such as break and continue allow you to alter the flow of a loop. Understanding control flow is crucial for writing efficient and effective Python programs. 2.4 Functions. In Python, a function is a block of reusable code that performs a specific task. It allows you to break down your program into smaller, more manageable pieces, making your code more organized and easier to understand. Functions also promote code reusability, as you can call a function multiple times throughout your program. Defining a function. To define a function in Python, you use the def keyword followed by the function name and a pair of parentheses. Inside the parentheses, you can specify any parameters that the function should accept. Parameters are variables that hold the values passed to the function when it is called. Here's an example of a simple function that takes two parameters and returns their sum. Def add underscore numbers a, b. Sum equals a plus b return sum. In this example, add underscore numbers is the name of the function, and a and b are the parameters. Inside the function, we calculate the sum of a and b and store it in the variable sum. Finally, we use the return keyword to return the sum as the result of the function. Calling a function. Once you have defined a function, you can call it by using its name followed by a pair of parentheses. If the function has parameters, you need to provide the values for those parameters inside the parentheses. Here's how you can call the add_numbers function from the previous example. Result equals add_numbers 5, 3 print result hash output 8. In this example, we pass the values 5 and 3 as arguments to the add_numbers function. The function calculates the sum of the two numbers and returns the result, which we store in the variable result. Finally, we print the value of result, which is 8. Default parameters. In Python, you can also define default values for function parameters. Default parameters are used when the caller does not provide a value for that parameter. Here's an example of a function with a default parameter. Def greet name equals John. Print hello plus name plus. In this example, the greet function has a default parameter name set to John. If the caller does not provide a value for name, the function will use the default value. If a value is provided, it will override the default value. Greet hash output hello John. Greet Alice hash output hello Alice. In the first call to greet, since no value is provided for name, the function uses the default value John. In the second call, we provide the value, Alice, so the function uses that value instead. Returning values. Functions in Python can return values using the return keyword. The value specified after the return keyword is the result of the function. Here's an example of a function that calculates the area of a rectangle and returns the result. Def calculate_area length, width. Area equals length * width return area. In this example, the calculate_area function takes two parameters, length and width. It calculates the area of the rectangle by multiplying the length and width and stores the result in the variable area. Finally, it returns the value of area as the result of the function. Result equals calculate_area 5, 3 print result hash output 15. In this example, we call the calculate_area function with the values 5 and 3 as arguments. The function calculates the area of the rectangle and returns the result, which we store in the variable result. Finally, we print the value of result, which is 15. Scope of variables. Variables defined inside a function are called local variables and are only accessible within that function. They are separate from variables defined outside the function, which are called global variables. Here's an example that demonstrates the scope of variables. Def my_function. X equals 10 hash local variable print x. X equals 5 hash global variable my_function hash output 10 print x hash output 5. In this example, we define a function my_function that has a local variable x set to 10. Inside the function, we print the value of x, which is 10. Outside the function, we have a global variable x set to 5. When we print the value of x outside the function, it prints 5. Conclusion. Functions are an essential part of programming in Python. They allow you to break down your code into smaller, reusable pieces, making your code more organized and easier to maintain. By using functions, you can write cleaner and more efficient code. 3. Data structures. 3.1 Lists. In Python, a list is a versatile and commonly used data structure that allows you to store and manipulate a collection of items. Lists are ordered, mutable, and can contain elements of different data types. They are denoted by square brackets, and individual elements are separated by commas. Creating a list. To create a list, you simply enclose the elements within square brackets. For example, fruits equals apple, banana, orange. In this example, we have created a list called fruits that contains 3 strings, apple, banana, and orange. Lists can also be empty, like this. Empty_list equals accessing list elements. You can access individual elements of a list by using their index. The index of the first element is 0, the second element is 1, and so on. For example, fruits equals apple, banana, orange, print fruits 0 hash output, apple print fruits 1 hash output, banana print fruits 2 hash output, orange. You can also use negative indexing to access elements from the end of the list. The index -1 refers to the last element, -2 refers to the second last element, and so on. For example, fruits equals apple, banana, orange, print fruits -1 hash output, orange print fruits -2 hash output, banana print fruits -3 hash output, apple modifying list elements. Lists are mutable, which means you can change the value of individual elements. You can assign a new value to an element by using its index. For example, fruits equals apple, banana, orange, fruits 1 equals grape. Print fruits hash output, apple, grape, orange. You can also modify multiple elements at once by using slicing. Slicing allows you to extract a portion of a list. For example, fruits equals apple, banana, orange, grape, kiwi, fruits 1, 4 equals mango, pear, melon, print fruits hash output, apple, mango, pear, melon, kiwi, list operations. Python provides several operations that can be performed on lists. Concatenation. You can concatenate two or more lists using the plus operator. This creates a new list that contains all the elements from the original lists. For example, list 1 equals 1, 2, 3, list 2 equals 4, 5, 6, concatenated underscore list equals list 1 plus list 2 print, concatenated underscore list, hash output, 1, 2, 3, 4, 5, 6, repetition. You can repeat a list multiple times using the asterisk operator. This creates a new list that contains the elements of the original list repeated the specified number of times. For example, list 1 equals 1, 2, 3, repeated underscore list equals list 1 asterisk 3. Print repeated underscore list, hash output, 1, 2, 3, 1, 2, 3, 1, 2, 3, length. You can determine the length of a list using the len function. This returns the number of elements in the list. For example, fruits equals apple, banana, orange, print len, fruits, hash output, 3 list methods. Python provides a variety of built-in methods that can be used to manipulate lists. Append. The append method is used to add an element to the end of a list. For example, fruits equals apple, banana, orange, fruits, append grape. Print fruits, hash output, apple, banana, orange, grape, insert. The insert method is used to insert an element at a specific position in a list. You need to specify the index where you want to insert the element. For example, fruits equals apple, banana, orange, fruits, insert 1, grape. Print fruits, hash output, apple, grape, banana, orange, remove. The remove method is used to remove the first occurrence of a specified element from a list. For example, fruits equals apple, banana, orange, fruits, remove banana, print fruits, hash output, apple, orange, pop. The pop method is used to remove and return an element from a specific position in a list. If no index is specified, it removes and returns the last element. For example, fruits equals apple, banana, orange, removed underscore fruit equals fruits.pop, 1 print removed underscore fruit, hash output, banana print fruits, hash output, apple, orange, sort. The sort method is used to sort the elements of a list in ascending order. For example, numbers equals 3, 1, 4, 2, numbers, sort. Print numbers, hash output, 1, 2, 3, 4, reverse. The reverse method is used to reverse the order of the elements in a list. For example, fruits equals apple, banana, orange, fruits, reverse. Print fruits, hash output, orange, banana, apple, list comprehensions. List comprehensions provide a concise way to create lists based on existing lists. They allow you to apply an expression to each element of a list and create a new list from the results. For example, numbers equals 1, 2, 3, 4, 5 squared underscore numbers equals x asterisk 2 for x in numbers print squared underscore numbers hash output 1, 4, 9, 16, 25. In this example, we square each element of the numbers list and create a new list called squared underscore numbers using a list comprehension. List comprehensions can also include conditional statements to filter the elements. For example, numbers equals 1, 2, 3, 4, 5 even underscore numbers equals x for x in numbers if x%2 equals O print even underscore numbers hash output 2, 4. In this example, we only include the elements from the numbers list that are divisible by 2 in the even underscore numbers list. Conclusion. Lists are a fundamental data structure in Python that allow you to store and manipulate collections of items. They are versatile, mutable, and provide a wide range of operations and methods for working with data. Understanding how to create, access, modify, and manipulate lists is essential for any Python programmer. 3.2 Tuples. In Python, a tuple is an ordered collection of elements, enclosed in parentheses and separated by commas. Tuples are similar to lists, but they are immutable, meaning that their elements cannot be modified once they are defined. This makes tuples useful for storing data that should not be changed, such as coordinates or configuration settings. Creating tuples. To create a tuple, you can simply enclose the elements in parentheses and separate them with commas. For example, my underscore tuple equals 1, 2, 3. You can also create a tuple without using parentheses, by separating the elements with commas. For example, my underscore tuple equals 1, 2, 3. Tuples can contain elements of different data types, including numbers, strings, and even other tuples. For example, mixed underscore tuple equals 1, hello, 4, 5, 6 accessing elements. You can access individual elements of a tuple using indexing, similar to how you would access elements in a list. The index of the first element is 0, the second element is 1, and so on. For example, my underscore tuple equals 1, 2, 3 print my underscore tuple, 0 hash output, 1 print my underscore tuple, 2 hash output, 3. You can also use negative indexing to access elements from the end of the tuple. The index of the last element is -1, the second to last element is -2, and so on. For example, my underscore tuple equals 1, 2, 3 print my underscore tuple, -1 hash output, 3 print my underscore tuple, -2 hash output, 2 tuple operations. Although tuples are immutable, you can perform various operations on them. Concatenation. You can concatenate two or more tuples using the plus operator. This creates a new tuple that contains all the elements from the original tuples. For example, tuple 1 equals 1, 2, 3 tuple 2 equals 4, 5, 6 concatenated underscore tuple equals tuple 1 plus tuple 2 print concatenated underscore tuple hash output 1, 2, 3, 4, 5, 6 repetition. You can repeat a tuple multiple times using the asterisk operator. This creates a new tuple that contains the elements of the original tuple repeated the specified number of times. For example, my underscore tuple equals 1, 2, 3 repeated underscore tuple equals my underscore tuple asterisk 3. Print repeated underscore tuple hash output 1, 2, 3, 1, 2, 3, 1, 2, 3 slicing. You can extract a portion of a tuple using slicing. Slicing allows you to specify a range of indices and create a new tuple that contains the elements within that range. For example, my underscore tuple equals 1, 2, 3, 4, 5 sliced underscore tuple equals my underscore tuple 1, 4 print sliced underscore tuple hash output 2, 3, 4 tuple methods. Tuples have a few built-in methods that allow you to perform certain operations on them. Count. The count method returns the number of times a specified element appears in a tuple. For example, my underscore tuple equals 1, 2, 2, 3, 3, 3 count equals my underscore tuple, count 2 print count hash output 2 index. The index method returns the index of the first occurrence of a specified element in a tuple. For example, my underscore tuple equals 1, 2, 3, 4, 5 index equals my underscore tuple, index 3 print index hash output 2 advantages of tuples. Tuples have several advantages over lists. Tuples are immutable, which means they cannot be modified once they are defined. This makes them safer to use in certain situations where you want to ensure that the data remains unchanged. Tuples are generally faster than lists, as they require less memory and have a smaller memory footprint. Tuples can be used as keys in dictionaries, whereas lists cannot. Conclusion. In this section, you learned about tuples in Python. Tuples are ordered collections of elements that are enclosed in parentheses and separated by commas. They are immutable, meaning that their elements cannot be modified once they are defined. Tuples can be created using parentheses or by separating the elements with commas. You can access elements of a tuple using indexing, and perform various operations on tuples such as concatenation, repetition, and slicing. Tuples also have built-in methods like count and index for performing specific operations. Tuples have advantages over lists in terms of immutability, speed, and usability as dictionary keys. 3.3 Dictionaries. In Python, a dictionary is a built-in data structure that allows you to store and retrieve data using key-value pairs. It is also known as an associative array or a hash map in other programming languages. Dictionaries are mutable, unordered, and can contain any type of data. They are incredibly useful when you need to store and access data quickly based on a specific key. Creating a dictionary. To create a dictionary in Python, you use curly braces and separate each key-value pair with a colon. The key is usually a string, but it can also be an integer or any other immutable data type. The value can be of any data type, including lists, tuples, or even other dictionaries. Here's an example of creating a dictionary. Student equals name, John, age, 20. Major, computer science, grades, 85, 90, 95. In this example, we have a dictionary called student with 4 key-value pairs. The keys are name, age, major, and grades, and the corresponding values are John, 20, computer science, and 85, 90, 95 respectively. Accessing values in a dictionary. To access a value in a dictionary, you can use the key as an index. Simply provide the key inside square brackets after the dictionary name. If the key exists in the dictionary, the corresponding value will be returned. If the key does not exist, a key error will be raised. Here's an example of accessing values in a dictionary. Print student name, hash output, John print student age, hash output, 20 print student grades, hash output, 85, 90, 95. In this example, we access the values of the name, age, and grades keys in the student dictionary. Modifying values in a dictionary. Dictionaries are mutable, which means you can modify the values associated with a key. To modify a value, you can use the key as an index and assign a new value to it. Here's an example of modifying values in a dictionary. Student age equals 21 student grades, append 100. Print student age, hash output, 21 print student grades, hash output, 85, 90, 95, 100. In this example, we modify the value of the age key to 21 and append 100 to the list associated with the grades key. Adding and removing key value pairs. You can add new key value pairs to a dictionary by assigning a value to a new key. If the key already exists, the value will be updated. To remove a key value pair from a dictionary, you can use the del keyword followed by the key. Here's an example of adding and removing key value pairs. Student email equals john@example.com. Print student hash output. Name, John, age, 21, major, computer science, grades, 85, 90, 95, 100 email, john@example.com. Del student major. Print student hash output. Name, John, age, 21, grades, 85, 90, 95, 100 email, john@example.com. In this example, we add a new key value pair, email, john@example.com, to the student dictionary. Then, we remove the major key value pair using the del keyword. Dictionary methods. Python provides several built-in methods to work with dictionaries. Here are some commonly used methods. Keys returns a list of all the keys in the dictionary. Values returns a list of all the values in the dictionary. Items returns a list of all the key value pairs in the dictionary as tuples. GetKey returns the value associated with the specified key. If the key does not exist, it returns none or a default value if provided. PopKey removes the key value pair associated with the specified key and returns the value. Clear removes all the key value pairs from the dictionary. Here's an example of using some of these methods. Print student. Keys hash output. Name, age, grades, email, print student. Values hash output. John, 21, 85, 90, 95, 100 john@example.com. Print student. Items hash output. Name, John, age, 21 grades, 85, 90, 95, 100 email, john@example.com. Print student.get name, hash output. John print student.get GPA, hash output, none. Print student.pop email, hash output. John@example.com print student hash output. Name, John, age, 21, grades, 85, 90, 95, 100. Student, clear print student hash output. In this example, we use the keys, values, and items methods to retrieve information about the student dictionary. We also use the get method to retrieve values and the pop method to remove a key value pair. Finally, we use the clear method to remove all the key value pairs from the dictionary. Dictionaries are a powerful data structure in Python that allow you to store and retrieve data efficiently using key value pairs. They are widely used in various applications, such as data processing, web development, and machine learning. Understanding how to work with dictionaries is essential for any Python programmer. 3.4 Sets. A set is an unordered collection of unique elements in Python. It is a powerful data structure that allows you to perform mathematical set operations such as union, intersection, and difference. In this section, we will explore the basics of sets and learn how to use them effectively in Python programming. Creating a set. To create a set in Python, you can use the set function or enclose a sequence of elements within curly braces. Let's see some examples. Hash creating an empty set my_set equals set. Print my_set hash output, set. Hash creating a set with elements my_set equals 1, 2, 3, 4, 5 print my_set hash output, 1, 2, 3, 4, 5. As you can see, a set can contain elements of different data types such as integers, floats, strings, and even other sets. However, a set cannot contain mutable elements like lists or dictionaries. Adding and removing elements. Sets are mutable, which means you can add or remove elements from them. To add elements to a set, you can use the add method. To remove elements, you can use the remove or discard method. Let's see some examples. My_set equals 1, 2, 3. Hash adding elements to the set my_set.add 4. Print my_set hash output, 1, 2, 3, 4. Hash removing elements from the set my_set, remove 2. Print my_set hash output, 1, 3, 4. My_set, discard 5 hash no error if element doesn't exist print my_set hash output, 1, 3, 4 set operations. Sets in Python support various mathematical set operations such as union, intersection, difference, and symmetric difference. These operations can be performed using built-in methods or operators. Let's explore each operation with examples. Union. The union of two sets contains all the unique elements from both sets. You can use the union method or the operator to perform the union operation. Let's see an example. Set 1 equals 1, 2, 3, set 2 equals 3, 4, 5. Hash union using the union method union_set equals set 1. Union set 2 print union_set hash output, 1, 2, 3, 4, 5. Hash union using the operator union_set equals set 1, set 2 print union_set hash output, 1, 2, 3, 4, 5 intersection. The intersection of two sets contains the common elements between them. You can use the intersection method or the AND operator to perform the intersection operation. Let's see an example. Set 1 equals 1, 2, 3, set 2 equals 3, 4, 5. Hash intersection using the intersection method intersection underscore set equals set 1. Intersection set 2 print intersection underscore set hash output 3. Hash intersection using the AND operator intersection underscore set equals set 1 and set 2 print intersection underscore set hash output 3 difference. The difference between two sets contains the elements that are present in the first set but not in the second set. You can use the difference method or the operator to perform the difference operation. Let's see an example. Set 1 equals 1, 2, 3, set 2 equals 3, 4, 5. Hash difference using the difference method difference underscore set equals set 1. Difference set 2 print difference underscore set hash output 1, 2. Hash difference using the operator difference underscore set equals set 1 set 2 print difference underscore set hash output 1, 2 symmetric difference. The symmetric difference between two sets contains the elements that are present in either of the sets, but not in both. You can use the symmetric underscore difference method or the caret operator to perform the symmetric difference operation. Let's see an example. Set 1 equals 1, 2, 3, set 2 equals 3, 4, 5. Hash symmetric difference using the symmetric underscore difference method symmetric underscore difference underscore set equals set 1. Symmetric underscore difference set 2 print symmetric underscore difference underscore set hash output 1, 2, 4, 5. Hash symmetric difference using the caret operator symmetric underscore difference underscore set equals set 1 caret set 2 print symmetric underscore difference underscore set hash output 1, 2, 4, 5 set membership and iteration. You can check if an element is present in a set using the in keyword. Sets also support iteration using loops. Let's see some examples. My underscore set equals 1, 2, 3, 4, 5. Hash checking membership print 3 in my underscore set hash output true print 6 in my underscore set hash output false. Hash iterating over a set for element in my underscore set. Print element set operations and methods summary. Here is a summary of the set operations and methods we have covered in this section. Creating a set function or notation adding elements, add method removing elements, remove or discard method union method or operator intersection method or an operator difference method or operator symmetric difference, symmetric underscore difference method or caret operator membership, in keyword. Iteration, for loop. Sets are a versatile data structure in Python that can be used to solve a wide range of problems. They are particularly useful when dealing with unique elements or performing mathematical set operations. Understanding how to create, manipulate, and perform operations on sets will greatly enhance your Python programming skills. 3.5 Working with files. In this section, we will explore how to work with files in Python. Files are an essential part of any programming language as they allow us to store and retrieve data. Python provides several built-in functions and methods to handle file operations efficiently. Opening and closing files. Before we can perform any operations on a file, we need to open it. Python provides the open function for this purpose. The open function takes two parameters, the file name and the mode in which we want to open the file. The mode can be R for reading, W for writing, or A for appending to an existing file. File equals open example.txt, R. Once we have finished working with a file, it is essential to close it to free up system resources. We can use the close method to close the file. File, close reading from files. To read the contents of a file, we can use the read method. This method reads the entire file and returns its contents as a string. File equals open example.txt, R, content equals file, read print content file, close. If we want to read only a specific number of characters from a file, we can pass the desired number as an argument to the read method. File equals open example.txt, R, content equals file, read 10 hash read the first 10 characters print content. File, close. We can also read a file line by line using the readLine method. This method reads a single line from the file and returns it as a string. File equals open example.txt, R, line 1 equals file, readline line 2 equals file, readline print line 1 print line 2 file, close. To read all the lines of a file and store them in a list, we can use the readlines method. File equals open example.txt, R, lines equals file, readlines for line in lines. Print line file, close writing to files. To write data to a file, we need to open it in write mode W, or append mode A. If the file does not exist, Python will create it for us. File equals open example.txt, W, file, write hello, world. File, close. If we open a file in write mode and write some content to it, the existing content of the file will be overwritten. To append content to an existing file, we can open it in append mode. File equals open example.txt, file, write this as a new line, file, close. File handling with context managers. Python provides a more convenient way to handle files using context managers. Context managers automatically take care of opening and closing files, ensuring that resources are properly released. With open example.txt, as file. Content equals file, read print content. In the above example, the with statement opens the file and assigns it to the file variable. We can then perform any file operations within the indented block. Once the block is exited, the file is automatically closed, even if an exception occurs. File navigation. Python provides several methods to navigate through a file. The seek method allows us to move the file pointer to a specific position within the file. File equals open example.txt, file, seek 5 hash move the file pointer to the 6th character content equals file, read. Print content file, close. The tell method returns the current position of the file pointer. File equals open example.txt, print file, tell hash print the current position of the file pointer file, close. File handling best practices. When working with files, it is essential to follow some best practices to ensure efficient and error-free code. Always close the file after you have finished working with it to free up system resources. Use context managers with statement to handle files whenever possible to ensure proper opening and closing. Handle exceptions when working with files to gracefully handle any errors that may occur. Use meaningful variable names when working with files to improve code readability. Avoid hardcoding file paths and use relative or absolute paths instead to make your code more portable. By following these best practices, you can write clean and robust code when working with files in Python. In this section, we learned how to open, read, write, and navigate through files in Python. We also explored best practices for file handling. Files are a crucial part of any programming language, and Python provides us with powerful tools to work with them efficiently. 4. Object-oriented programming. 4.1 Classes and objects. In Python, as in many other programming languages, object-oriented programming (OOP) is a powerful paradigm that allows you to organize your code into reusable and modular components. At the core of OOP are classes and objects. What are classes? A class is a blueprint or template for creating objects. It defines a set of attributes, variables, and methods, functions that the objects of that class will have. Think of a class as a blueprint for a house, where the attributes define the characteristics of the house, such as the number of rooms, color, and size, and the methods define the actions that can be performed on the house, such as opening doors, turning on lights, and playing music. What are objects? An object is an instance of a class. It is a concrete entity that is created based on the blueprint provided by the class. Continuing with the house analogy, an object would be an actual house built based on the blueprint. Each object created from a class has its own set of attributes and can perform the actions defined by the class's methods. Creating a class. To create a class in Python, you use the class keyword followed by the name of the class. By convention, class names are written in camel case. Here's an example of a simple class called person. Class person. Def __init self, name, age self.name equals name self.age equals age. Def greet self. Print f, hello, my name is self.name, and I am self.age years old. In this example, the person class has two attributes, name and age. The __init__ method is a special method called the constructor, which is automatically called when an object is created from the class. It initializes the attributes of the object with the values passed as arguments. The greet method is a simple method that prints a greeting message using the object's name and age attributes. Creating objects. Once you have defined a class, you can create objects, instances, of that class using the class name followed by parentheses. Here's an example of creating two person objects. Person 1 equals person Alice, 25. Person 2 equals person Bob, 30. In this example, person 1 and person 2 are two objects created from the person class. Each object has its own set of attributes, name and age, and can perform the actions defined by the class's methods, such as calling the greet method. Accessing attributes and calling methods. To access the attributes of an object, you use dot notation. For example, to access the name attribute of person 1, you would write person1.name. Similarly, to call a method of an object, you use dot notation followed by parentheses. For example, to call the greet method of person 1, you would write person1, greet. Print person1, name hash output, Alice person1, greet hash output, hello, my name is Alice and I am 25 years old. Modifying attributes. You can modify the attributes of an object by assigning new values to them. For example, to change the age attribute of person 1, you would write person1.age equals 26. Person1.age equals 26. Print person1, age hash output, 26 class variables versus instance variables. In addition to instance variables, attributes that are specific to each object, classes can also have class variables, attributes that are shared by all objects of the class. Class variables are defined outside of any method in the class and are accessed using the class name. Class person. Species equals, human. Def underscore underscore init underscore underscore self, name, aged self dot name equals name self dot age equals age. Person 1 equals person, Alice, 25 person 2 equals person, Bob, 30. Print person 1, species hash output, human print person 2, species hash output, human. In this example, the species attribute is a class variable that is shared by all person objects. Any changes made to the class variable will be reflected in all objects. Summary. In this section, you learned about classes and objects in Python. A class is a blueprint for creating objects, and an object is an instance of a class. You can define attributes and methods in a class, and each object created from the class will have its own set of attributes and can perform the actions defined by the methods. You can access and modify the attributes of an object using dot notation, and you can create class variables that are shared by all objects of the class. 4.2 Inheritance. Inheritance is a fundamental concept in object-oriented programming that allows you to create new classes based on existing classes. It is a mechanism that enables you to define a new class, called the derived class or subclass, by inheriting the properties and behaviors of an existing class, called the base class or superclass. Inheritance promotes code reuse and allows you to create a hierarchy of classes with increasing levels of specialization. The syntax of inheritance. In Python, you can implement inheritance by using the class keyword followed by the name of the derived class, a pair of parentheses, and the name of the base class. The syntax for defining a derived class that inherits from a base class is as follows. Class derived class base class. Hash class body. The derived class inherits all the attributes and methods of the base class, including any public, protected, or private members. It can also define its own attributes and methods or override the ones inherited from the base class. Single inheritance. The most common form of inheritance is single inheritance, where a derived class inherits from a single base class. This allows the derived class to inherit all the attributes and methods of the base class. Let's consider an example to illustrate this concept. Class animal. Def underscore underscore init underscore underscore self, name self dot name equals name. Def speak self. Print the animal makes a sound. Class dog animal. Def underscore underscore init underscore underscore self, name, breed, super underscore underscore init underscore underscore name self, breed equals breed. Def speak self print the dog barks. Dog equals dog buddy, Labrador, print dog dot name, hash output, buddy dog, speak hash output, the dog barks. In this example, we have a base class called animal with an underscore underscore init underscore underscore method and a speak method. The derived class dog inherits from animal and adds its own underscore underscore init underscore underscore method and speak method. The super function is used to call the base class's underscore underscore init underscore underscore method to initialize the name attribute. The speak method in the dog class overrides the speak method in the animal class. Multiple inheritance. Python also supports multiple inheritance, where a derived class can inherit from multiple base classes. This allows the derived class to inherit attributes and methods from multiple sources. The syntax for multiple inheritance is similar to single inheritance, but with multiple base classes separated by commas. Class derived class base class 1, base class 2. Hash class body. Let's consider an example to understand multiple inheritance. Class shape. Def underscore underscore init underscore underscore self, color self, color equals color. Def draw self print drawing shape. Class fillable. Def fill self. Print filling shape with color. Class rectangle shape, fillable. Def underscore underscore init underscore underscore self, color, width, height super underscore underscore init underscore underscore colored self, width equals width self, height equals height. Def draw self print drawing rectangle. Rectangle equals rectangle red, 5, 3 print rectangle, color hash output, red rectangle, draw hash output, drawing rectangle. Rectangle, fill hash output, filling shape with color. In this example, we have two base classes, shape and fillable, and a derived class rectangle that inherits from both base classes. The rectangle class overrides the draw method from the shape class and inherits the fill method from the fillable class. The super function is used to call the underscore underscore init underscore underscore method of the shape class to initialize the color attribute. Method resolution order, MRO. When a class inherits from multiple base classes, Python uses a method resolution order, MRO, to determine the order in which it should search for methods. The MRO is determined by the C3 linearization algorithm, which ensures that all base classes are visited in a consistent and predictable order. You can view the MRO of a class by using the MRO method or the underscore underscore MRO underscore underscore attribute. Let's consider an example to understand the MRO. Class A. Def method self print A. Class B A. Def method self print B. Class C A. Def method self print C. Class D B C. Pass. D equals D. D, method hash output, B. Print d.maro hash output, less than class, underscore underscore main underscore underscore. D, greater than, less than class, underscore underscore main underscore underscore. B, greater than, less than class, underscore underscore main underscore underscore. C, greater than, less than class, underscore underscore main underscore underscore. A, greater than, less than class, object, greater than. In this example, we have 4 classes, A, B, C, and D. The D class inherits from both B and C, which in turn inherit from A. When the method is called on an instance of D, it prints B, because B is the first class in the MRO that defines the method. Overriding methods. Inheritance allows you to override methods inherited from the base class in the derived class. This means that you can provide a different implementation for a method in the derived class. To override a method, you simply define a method with the same name in the derived class. Let's consider an example. Class vehicle. Def drive self print driving vehicle. Class car vehicle. Def drive self print driving car. Vehicle equals vehicle. Vehicle, drive hash output, driving vehicle. Car equals car. Car, drive hash output, driving car. In this example, we have a base class vehicle with a drive method. The derived class car overrides the drive method and provides its own implementation. When the drive method is called on an instance of car, it prints driving car instead of driving vehicle. Conclusion. Inheritance is a powerful feature of object-oriented programming that allows you to create new classes based on existing classes. It promotes code reuse and enables you to create a hierarchy of classes with increasing levels of specialization. In Python, you can implement inheritance using the class keyword and the name of the base class. You can use single inheritance to inherit from a single base class or multiple inheritance to inherit from multiple base classes. The method resolution order (MRO) determines the order in which methods are searched for in multiple inheritance. You can override methods inherited from the base class in the derived class to provide a different implementation. 4.3 Polymorphism. Polymorphism is a fundamental concept in object-oriented programming (OOP) that allows objects of different classes to be treated as objects of a common superclass. It enables the same method to be called on different objects, resulting in different behaviors depending on the type of the object. Polymorphism promotes code reusability, flexibility, and extensibility, making it a powerful tool in software development. Understanding polymorphism. Polymorphism is derived from the Greek words, poly, meaning many, and morph, meaning form. In the context of OOP, it refers to the ability of an object to take on many forms. This concept is closely related to inheritance, as polymorphism relies on the inheritance hierarchy to achieve its functionality. At its core, polymorphism allows objects of different classes to be treated as objects of a common superclass. This means that if a class inherits from a superclass, it can be used wherever the superclass is expected. This is possible because the subclass inherits all the attributes and methods of the superclass, and can also define its own unique attributes and methods. Polymorphic method calls. One of the key features of polymorphism is the ability to call the same method on different objects, resulting in different behaviors. This is achieved through method overriding, where a subclass provides its own implementation of a method that is already defined in its superclass. Consider a simple example where we have a superclass called shape and 2 subclasses called circle and rectangle. The shape class has a method called area that calculates the area of the shape. Both the circle and rectangle classes inherit from the shape class and provide their own implementation of the area method. Class shape. Def area self pass. Class circle shape. Def underscore underscore init underscore underscore self, radius equals radius. Def area self. Return 3.14 asterisk self, radius asterisk self, radius. Class rectangle shape. Def underscore underscore init underscore underscore self, length, width self, length equals length self, width equals width. Def area self return self, length asterisk self, width. In the above example, the circle class overrides the area method to calculate the area of a circle using the formula pi r squared, where r is the radius. The rectangle class overrides the area method to calculate the area of a rectangle using the formula length asterisk width. Now, we can create objects of both the circle and rectangle classes and call the area method on them. Despite calling the same method, the behavior will be different based on the type of the object. Circle equals circle 5, rectangle equals rectangle 4, 6. Print circle, area hash output, 78.5. Print rectangle, area hash output, 24. In the above code, the circle object calls the area method defined in the circle class, which calculates the area of a circle. The rectangle object calls the area method defined in the rectangle class, which calculates the area of a rectangle. This demonstrates how polymorphism allows objects of different classes to be treated as objects of a common superclass. Polymorphism and inheritance. Polymorphism relies on the inheritance hierarchy to achieve its functionality. By defining a common superclass and allowing subclasses to inherit from it, polymorphism enables objects of different classes to be treated uniformly. In the previous example, the shape class acts as the common superclass for both the circle and rectangle classes. This means that any object of the circle or rectangle class can be treated as an object of the shape class. This allows for greater flexibility and extensibility in the code. For example, we can create a list of shape objects and add both circle and rectangle objects to it. We can then iterate over the list and call the area method on each object, regardless of its specific type. Shapes equals circle 5, rectangle 4, 6. For shape in shapes. Print shape area. In the above code, the shapes list contains both a circle object and a rectangle object. The for loop iterates over each object in the list and calls the area method on it. Despite the objects being of different types, polymorphism allows the area method to be called on each object, resulting in the appropriate behavior based on the type of the object. Benefits of polymorphism. Polymorphism offers several benefits in software development. Code reusability. Polymorphism allows for the reuse of code by defining common methods in a superclass and allowing subclasses to inherit and override them as needed. This promotes code reuse and reduces redundancy. Flexibility. Polymorphism provides flexibility by allowing objects of different classes to be treated as objects of a common superclass. This enables the code to be more adaptable to changes and promotes modularity. Extensibility. Polymorphism allows for easy extension of functionality by adding new subclasses that inherit from a common superclass. This makes it easier to add new features or modify existing ones without affecting the existing codebase. Simplified code. Polymorphism simplifies code by allowing for more generic programming. Instead of writing separate code for each specific class, polymorphism allows for a more generalized approach, reducing the overall complexity of the code. Overall, polymorphism is a powerful concept in OOP that promotes code reusability, flexibility, and extensibility. By allowing objects of different classes to be treated as objects of a common superclass, polymorphism enables the same method to be called on different objects, resulting in different behaviors based on the type of the object. 4.4 Encapsulation. Encapsulation is one of the fundamental principles of object-oriented programming (OOP). It refers to the bundling of data and methods within a class, and controlling access to them from outside the class. Encapsulation helps in organizing code, improving code maintainability, and reducing code complexity. In Python, encapsulation is achieved through the use of access modifiers. Access modifiers are keywords that determine the visibility and accessibility of class members, variables, and methods. There are three types of access modifiers in Python: public, protected, and private. Public access modifier. By default, all class members in Python are public, which means they can be accessed from anywhere, both within and outside the class. Public members are denoted by not using any access modifier keyword. Class my class. Def __init self public _var equals 10. Def public method self print. This is a public method. In the above example, public _var and public method are public members of the myClass. They can be accessed using an instance of the class. obj equals myClass. Print obj public _var #output 10 obj public method #output. This is a public method. Protected access modifier. Protected members are denoted by a single __ prefix. They can be accessed within the class and its subclasses, but not from outside the class hierarchy. Class my class. Def __init self protected _var equals 20. Def protected method self print. This is a protected method. In the above example, protected var and protected method are protected members of the myClass class. They can be accessed within the class and its subclasses. Class my subclass, my class. Def __init self super __init Def access protected self print self protected var #output 20 self protected method #output. This is a protected method. Private access modifier. Private members are denoted by a double ___ prefix. They can only be accessed within the class itself and cannot be accessed from outside the class. Class my class. Def __init self private var equals 30. Def private method self print. This is a private method. In the above example, private var and private method are private members of the myClass class. They can only be accessed within the class itself. obj equals myClass. Print obj private var raises an attribute error obj private method raises an attribute error. However, Python provides a name mangling mechanism to access private members from outside the class. Private members can be accessed using the _classname _private member syntax. obj equals my class. Print obj underscore my class underscore underscore private underscore var hash output 30 obj underscore my class underscore underscore private underscore method hash output. This is a private method. Benefits of encapsulation. Encapsulation provides several benefits in software development. Data hiding. Encapsulation allows hiding the internal details of a class from the outside world. This helps in preventing unauthorized access and manipulation of data. Code organization. Encapsulation helps in organizing code by grouping related data and methods within a class. This improves code readability and maintainability. Code reusability. Encapsulation promotes code reusability by encapsulating common functionality within classes. These classes can then be reused in different parts of the program or in other programs. Code flexibility. Encapsulation allows for easy modification of the internal implementation of a class without affecting the code that uses the class. This improves code flexibility and reduces the impact of changes. Code security. Encapsulation provides a level of security by controlling access to class members. By using access modifiers, you can restrict access to sensitive data and methods, preventing unauthorized modifications. Best practices for encapsulation. To effectively use encapsulation in your Python programs, consider the following best practices. Use access modifiers wisely. Choose the appropriate access modifier for each class member based on its intended visibility and accessibility. Use public members for data and methods that need to be accessed from outside the class, protected members for data and methods that need to be accessed within the class hierarchy, and private members for data and methods that should only be accessed within the class. Follow naming conventions. Use meaningful and descriptive names for class members to improve code readability. Use a single underscore prefix for protected members and a double underscore prefix for private members. This convention helps in distinguishing between different types of class members. Avoid direct access to data. Encapsulate data within classes and provide getter and setter methods to access and modify the data. This allows for better control over data access and enables validation and error handling. Minimize exposure of implementation details. Hide the internal implementation details of a class from the outside world. Only expose the necessary functionality through public methods, while keeping the internal state and implementation hidden. Document class interfaces. Provide clear and concise documentation for the public methods and properties of a class. This helps other developers understand how to use the class and its members correctly. By following these best practices, you can effectively utilize encapsulation in your Python programs, leading to more maintainable and robust code. 5. Modules and packages. 5.1 Creating modules. In Python, a module is a file containing Python definitions and statements. It serves as a way to organize and reuse code. Modules can contain functions, classes, and variables that can be used in other Python programs. Creating modules allows you to break down your code into smaller, more manageable pieces, making it easier to maintain and debug. To create a module, you simply need to create a new Python file with a py extension. For example, if you want to create a module called math_operations, you would create a file named math_operations.py. Inside this file, you can define functions, classes, and variables that will be accessible to other Python programs. Let's create a simple module called math_operations to demonstrate how it works. Open a new file in your text editor and save it as math_operations.py. In this module, we will define a few basic mathematical operations. Hash math_operations.py. Def add a, b. Return a plus b. Def subtract a, b. Return a, b. Def multiply a, b. Return a asterisk b. Def divide a, b. Return a, b. In the above example, we have defined 4 functions: add, subtract, multiply, and divide. Each function takes 2 arguments and performs the corresponding mathematical operation. Now, let's see how we can use this module in another Python program. Hashmain.py. Import math_operations. Result equals math_operations.add 5, 3 print result hash output, 8. Result equals math_operations. Subtract 10, 4 print result hash output, 6. Result equals math_operations. Multiply 2, 5 print result hash output, 10. Result equals math_operations. Divide 15, 3 print result hash output, 5. In the above example, we import the math_operations module using the import statement. This allows us to access the functions defined in the module. We can then call these functions and store the results in variables. Finally, we print the results to the console. When running the main.py program, the output will be 86105. As you can see, we were able to use the functions defined in the math_operations module to perform various mathematical operations. It's important to note that when importing a module, Python searches for the module in the directories listed in the sys path variable. By default, this includes the current directory and the directories specified in the Python path environment variable. If the module is not found in any of these directories, a module not found error will be raised. You can also create modules that only contain variables or classes. The process is the same: define the variables or classes in the module file and import them in other Python programs. Creating modules allows you to organize your code into logical units and promotes code reuse. Instead of writing the same code over and over again in different programs, you can simply import the module and use its functions, classes, or variables. This not only saves time but also makes your code more maintainable and easier to understand. In addition to creating your own modules, Python provides a rich library of built-in modules that you can import and use in your programs. These modules provide a wide range of functionality, including mathematical operations, file handling, networking, and more. You can explore the Python documentation to learn more about the available modules and their usage. In summary, creating modules in Python allows you to organize and reuse your code. Modules can contain functions, classes, and variables that can be imported and used in other Python programs. By breaking down your code into smaller, more manageable pieces, you can improve code maintainability and promote code reuse. 5.2 Importing modules. In Python, modules are files that contain Python code, which can be used to define functions, classes, and variables. These modules can be imported into other Python programs to reuse code and access the functionality provided by the module. Importing modules allows you to extend the capabilities of your program without having to write all the code from scratch. The import statement. To import a module in Python, you use the import statement followed by the name of the module. For example, to import the math module, you would write import math. This statement makes all the functions and variables defined in the math module available in your program. You can then use these functions and variables by prefixing them with the module name, followed by a dot. For example, to use the sqrt function from the math module, you would write result equals math, sqrt 25. Here, the sqrt function is called using the module name math followed by a dot, and the argument 25 is passed to the function. The result of the function call is assigned to the variable result. Importing specific functions or variables. Sometimes, you may only need to use a specific function or variable from a module, rather than importing the entire module. In such cases, you can import only the required functions or variables using the from keyword. For example, to import only the sqrt function from the math module, you would write from math import sqrt. This statement imports only the sqrt function from the math module, making it available directly in your program without having to prefix it with the module name. You can then use the function directly, like this. Result equals sqrt 25 importing with aliases. In some cases, you may want to import a module or function with a different name to avoid naming conflicts or to make the code more readable. You can do this by using the as keyword to assign an alias to the module or function. For example, to import the math module with the alias m, you would write import math as m. This statement imports the math module and assigns it the alias m. You can then use the functions and variables from the math module by prefixing them with the alias m. For example, result equals m, sqrt 25. Here, the sqrt function is called using the alias m followed by a dot, and the argument 25 is passed to the function. Importing all functions and variables. If you want to import all the functions and variables from a module without having to prefix them with the module name or an alias, you can use the asterisk wildcard character. For example, to import all the functions and variables from the math module, you would write from math import. This statement imports all the functions and variables from the math module, making them available directly in your program. However, it is generally recommended to avoid using the asterisk wildcard import, as it can make the code less readable and may lead to naming conflicts. Importing modules from packages. In Python, a package is a way to organize related modules into a directory hierarchy. To import a module from a package, you use the dot notation. For example, if you have a package named my_package with a module named my_module, you would import the module like this. Import my_package.my_module. This statement imports the my_module module from the my_package package. You can then use the functions and variables from the module by prefixing them with the package name and module name, separated by dots. For example, result equals my_package.my_module.my_function 25. Here, the my_function from the my_module is called using the package name my_package, followed by a dot, the module name my_module, and another dot. The argument 25 is passed to the function, and the result is assigned to the variable result. Conclusion. Importing modules is an essential part of Python programming. It allows you to reuse code, extend the functionality of your programs, and organize your code into logical units. By using the import statement, you can import modules, specific functions or variables, and even assign aliases to them. Understanding how to import modules effectively will help you write more efficient and maintainable Python programs. 5.3 Working with packages. In Python, a package is a way to organize related modules into a single directory hierarchy. It provides a way to group related functionality together, making it easier to manage and reuse code. Packages are an essential part of Python's module system and are widely used in the Python ecosystem. Creating a package. To create a package, you need to follow a specific directory structure. The top-level directory of the package should have a special file called __init___.py. This file can be empty or can contain initialization code for the package. The __init___.py file is what makes a directory a Python package. Let's say you want to create a package called my_package. You would start by creating a directory with the same name. Inside the my_package directory, you would create the __init___.py file. You can also create other Python modules inside the package directory. My_package. __init___.py module1.py module2.py. In this example, my_package is the package name, and module1.py and module2.py are the modules within the package. The __init___.py file can be left empty for now. Importing from a package. Once you have created a package, you can import modules from it using the import statement. To import a module from a package, you need to specify the package name followed by the module name, separated by a dot. For example, if you have a module called module1 inside the my_package package, you can import it like this. Import my_package, module1. Alternatively, you can use the from keyword to import specific objects from a module within a package. From my_package, module1 imports some underscore function. This allows you to use the function directly without having to specify the module name every time. Accessing subpackages. Packages can also contain subpackages, which are simply packages within packages. To access a subpackage, you can use the dot notation to navigate through the package hierarchy. For example, if you have a subpackage called sub_package inside the my_package package, you can import a module from the subpackage like this. Import my_package.sub_package, module 3. You can also use the from keyword to import specific objects from a module within a subpackage. From my_package.sub_package, module 3 imports some underscore function package initialization. The __init__.py file in a package serves as the initialization code for the package. It is executed when the package is imported. This file can contain any Python code, such as variable assignments, function definitions, or import statements. For example, let's say you have the following code in the __init___.py file of the my_package package. Print initializing my_package. Some_variable equals 10. Def some_function. Print hello from my_package. When you import the my_package package, the initialization code will be executed, and the output will be initializing my_package. You can also use the __init___.py file to control what gets imported when the package is imported. By default, when you import a package, only the __init___.py file is executed. If you want to import specific modules or objects from the package, you can define them in the __init___.py file using the __all__ variable. For example, let's say you have the following code in the __init___.py file of the my_package package. __all__ equals module1 foot. Print initializing my_package. Some_variable equals 10. Def some_function. Print hello from my_package. When you import the my_package package, only the module1 module will be imported. The output will be initializing my_package installing and distributing packages. Python packages can be distributed and installed using the Python package index, PyPI, and the pip package manager. PyPI is a repository of Python packages that allows developers to share and distribute their packages. To distribute a package, you need to create a setup.py file that contains information about the package, such as its name, version, and dependencies. You can also include additional files, such as documentation or example code. Once you have created the setup.py file, you can use the pip command to build and install the package. The pip command will automatically download and install any dependencies specified in the setup.py file. To install a package from PyPI, you can use the following command. Pip install package_name. Where package_name is the name of the package you want to install. Conclusion. Working with packages in Python allows you to organize and manage your code more effectively. Packages provide a way to group related modules together, making it easier to reuse and distribute code. By following the correct directory structure and using the __init___.py file, you can create and import packages in your Python projects. Additionally, you can distribute your packages using pip in the pip package manager, making it easier for others to install and use your code. 5.4 Using external libraries. Python is a powerful programming language that comes with a wide range of built-in libraries and modules. However, there are times when you may need to use external libraries to extend the functionality of your Python programs. External libraries are collections of pre-written code that provide additional features and capabilities beyond what is available in the standard Python library. Using external libraries in Python is relatively straightforward. The first step is to install the library on your system. Most libraries can be installed using Python's package manager, pip. Pip is a command line tool that allows you to easily install, uninstall, and manage Python packages. To install a library using pip, you need to open a terminal or command prompt and run the following command. Pip install library_name. Replace library_name with the name of the library you want to install. For example, if you want to install the popular NumPy library, you would run pip install NumPy. Once the library is installed, you can import it into your Python program using the import statement. The import statement allows you to access the functions, classes, and variables defined in the library. Here's an example of how to import the NumPy library. Import NumPy. After importing the library, you can use its functions and classes in your program. For example, NumPy provides a powerful array object that allows you to perform mathematical operations on large sets of data. You can create a NumPy array and perform operations on it like this. Import NumPy as NP. Hash create a NumPy array arranged by equals NP. Array 1, 2, 3, 4, 5. Hash perform operations on the array print NP. Mean arranged by hash calculate the mean of the array print NP.max arranged by hash find the maximum value in the array. In addition to the import statement, you can also use the from keyword to import specific functions or classes from a library. This allows you to use the imported functions or classes directly without having to prefix them with the library name. Here's an example of how to import the sqrt function from the math library. From math import sqrt. Hash use the sqrt function directly result equals sqrt 16 print result. Some libraries have long or complex names, which can make them cumbersome to use in your code. In such cases, you can use the as keyword to give the library a shorter alias. This alias can then be used to refer to the library in your code. Here's an example of how to import the pandas library and give it the alias pd. Import pandas as pd. Hash use the pandas library using the alias pd data equals pd, read_csv data.csv. Using external libraries can greatly enhance your Python programming experience. They provide ready-made solutions to common problems and allow you to leverage the work of other developers. However, it's important to choose libraries carefully and only use those that are well maintained and have a good reputation within the Python community. Before using an external library, it's a good idea to read its documentation to understand its features, usage, and any dependencies it may have. The documentation will also provide examples and code snippets that demonstrate how to use the library effectively. In addition to the official documentation, there are many online resources and communities where you can find tutorials, guides, and discussions about using specific libraries. These resources can be invaluable in helping you learn how to use a library and solve problems using its features. When using external libraries, it's important to keep them up to date. Library developers regularly release updates that fix bugs, add new features, and improve performance. To update a library, you can use the pip command with the upgrade flag. Pip install upgrade library_name. Using external libraries is a fundamental skill for any Python programmer. It allows you to leverage the work of others and build more powerful and efficient programs. By understanding how to install, import, and use external libraries, you can take your Python programming skills to the next level and tackle a wide range of projects and problems. 6. Error handling and exceptions. 6.1 Understanding errors. Errors are an inevitable part of programming. No matter how experienced you are, you will encounter errors while writing code. Understanding errors and knowing how to handle them is crucial for writing robust and reliable programs. Types of errors. In Python, errors are categorized into three main types: syntax errors, runtime errors, and logical errors. Syntax errors. Syntax errors occur when the code violates the rules of the Python language. These errors are detected by the Python interpreter during the parsing phase, before the code is executed. Common syntax errors include missing parentheses, incorrect indentation, and misspelled keywords. For example, consider the following code snippet. Print, hello, world. In this case, a syntax error will be raised because the closing parenthesis is missing. The Python interpreter will display a traceback message indicating the line number and the nature of the error. Runtime errors. Runtime errors, also known as exceptions, occur during the execution of a program. These errors are caused by factors such as invalid input, division by zero, or accessing an index out of range. Runtime errors can be handled using exception handling techniques, which we will discuss in the next section. For example, consider the following code snippet. num1 equals 10 num2 equals 0. Result equals num1, num2. In this case, a runtime error called zero division error will be raised because we are trying to divide a number by 0. The Python interpreter will display a traceback message indicating the line number and the specific exception that occurred. Logical errors. Logical errors, also known as semantic errors, occur when the code does not produce the expected output due to a flaw in the logic or algorithm. These errors are the most difficult to detect and fix because they do not cause the program to crash or raise an exception. Instead, they result in incorrect or unexpected behavior. For example, consider the following code snippet. Radius equals 5. Area equals 2 *3.14 radius. In this case, a logical error will occur because the formula used to calculate the area of a circle is incorrect. The correct formula should be 3.14 radius. The program will run without any errors, but the calculated area will be incorrect. Reading error messages. When an error occurs, Python provides an error message called a traceback. The traceback contains valuable information that can help you identify and fix the error. It includes the type of error, the line number where the error occurred, and a description of the error. For example, consider the following code snippet. num1 equals 10 num2 equals 5 inches result equals num1 plus num2. In this case, a runtime error called type error will be raised because we are trying to add an integer and a string. The traceback message will indicate the line number and the specific exception that occurred. Reading and understanding the traceback message is essential for debugging your code. It allows you to pinpoint the exact location of the error and understand the cause of the problem. Debugging techniques. Debugging is the process of identifying and fixing errors in your code. Here are some techniques that can help you debug your Python programs. Print statements. One of the simplest and most effective debugging techniques is to use print statements. By strategically placing print statements in your code, you can track the flow of execution and inspect the values of variables at different points. For example, consider the following code snippet. Def calculate _area radius. Print calculating area. Area equals 3.14 radius print, area calculated successfully. Return area. Radius equals 5. Area equals calculate _area radius print, the area of the circle is area. In this case, we have added print statements to track the execution flow and verify the calculated area. By examining the output, we can ensure that the code is working as expected. Using a debugger. Python provides a built-in debugger called PDB, Python Debugger, that allows you to step through your code and inspect variables at runtime. The debugger allows you to set breakpoints, execute code line by line, and examine the state of your program. To use the debugger, you need to import the PDB module and set a breakpoint at the desired location in your code. When the program reaches the breakpoint, it will pause execution, and you can interactively inspect the variables and step through the code. Reading documentation and seeking help. When encountering errors or difficulties, it is essential to consult the official Python documentation and seek help from the Python community. The documentation provides detailed explanations of Python's features, modules, and functions, along with examples and usage guidelines. Additionally, online forums, discussion boards, and programming communities like Stack Overflow can be valuable resources for finding solutions to common programming problems. Asking questions and seeking guidance from experienced programmers can help you overcome challenges and improve your coding skills. Conclusion. Understanding errors and knowing how to handle them is a fundamental skill for any Python programmer. By familiarizing yourself with the different types of errors, reading and interpreting error messages, and using effective debugging techniques, you can write more robust and reliable code. Remember, errors are opportunities for learning and improvement, so embrace them as part of your programming journey. 6.2 Handling exceptions. In Python, exceptions are a way to handle errors and unexpected situations that may occur during the execution of a program. When an error occurs, Python raises an exception, which can be caught and handled by the program. This allows the program to gracefully recover from errors and continue executing without crashing. The try except block. The most common way to handle exceptions in Python is by using the try except block. The try block contains the code that may raise an exception, and the except block specifies the code to be executed if an exception is raised. Here's the basic syntax. Try. Hash code that may raise an exception except exception type. Hash code to handle the exception. In the try block, you write the code that you want to execute. If an exception is raised during the execution of this code, Python will jump to the except block and execute the code inside it. The exception type specifies the type of exception that you want to catch. You can catch specific exceptions or use a more general exception to catch any type of exception. Handling specific exceptions. To handle specific exceptions, you can specify the type of exception in the except block. For example, if you want to handle a value error, you can write try. Hash code that may raise a value error except value error. Hash code to handle the value error. In this case, if a value error is raised in the try block, the code inside the except block will be executed. You can have multiple except blocks to handle different types of exceptions. If an exception is raised that doesn't match any of the specified types, it will not be caught and will propagate up the call stack. Handling multiple exceptions. You can also handle multiple exceptions in a single except block by specifying multiple exception types. This can be useful when you want to handle different exceptions in the same way. Here's an example. Try. Hash code that may raise multiple exceptions except exception type 1, exception type 2. Hash code to handle the exceptions. In this case, if either exception type 1 or exception type 2 is raised in the try block, the code inside the except block will be executed. You can list as many exception types as you need, separated by commas. Handling all exceptions. If you want to catch any type of exception, you can use the generic exception type in the except block. This can be useful when you want to handle all exceptions in the same way. Here's an example. Try. Hash code that may raise an exception except exception. Hash code to handle the exception. In this case, if any exception is raised in the try block, the code inside the except block will be executed. However, it's generally recommended to catch specific exceptions whenever possible, as catching all exceptions can make it harder to debug and maintain your code. The else block. In addition to the try and except blocks, you can also include an else block after the except block. The code inside the else block will be executed if no exceptions are raised in the try block. This can be useful when you want to perform some additional actions after the try block has executed successfully. Here's an example. Try. Hash code that may raise an exception except exception type. Hash code to handle the exception else. Hash code to execute if no exceptions are raised. In this case, if no exceptions are raised in the try block, the code inside the else block will be executed. If an exception is raised, the code inside the except block will be executed instead. The finally block. The finally block is used to specify code that should always be executed, regardless of whether an exception is raised or not. This block is optional and is placed after the except and else blocks. The code inside the finally block will be executed even if an exception is raised and not caught. Here's an example. Try. Hash code that may raise an exception except exception type. Hash code to handle the exception else. Hash code to execute if no exceptions are raised finally. Hash code to execute regardless of exceptions. In this case, the code inside the finally block will always be executed, regardless of whether an exception is raised or not. This can be useful when you need to clean up resources or perform some final actions before the program exits. Raising exceptions. In addition to handling exceptions, you can also raise your own exceptions in Python. This can be useful when you want to indicate that an error has occurred in your code. To raise an exception, you can use the raise statement followed by the type of exception you want to raise. Here's an example. Raise exception type error message. In this case, the raise statement will raise an exception of type exception type with a specified error message. You can raise any type of exception, including built-in exceptions or custom exceptions that you define. Conclusion. Handling exceptions is an important part of writing robust and reliable Python programs. By using the try except block, you can catch and handle exceptions, allowing your program to gracefully recover from errors. Remember to catch specific exceptions whenever possible and use the else and finally blocks to perform additional actions as needed. 6.3 Raising exceptions. In Python, exceptions are a way to handle errors in exceptional situations that may occur during the execution of a program. However, there are cases where you may want to explicitly raise an exception yourself. This can be useful when you want to indicate that something unexpected or erroneous has occurred in your code. To raise an exception in Python, you can use the raise statement followed by the type of exception you want to raise. For example, if you want to raise a value error exception, you can do so by writing raise value error. You can also provide an optional error message as an argument to the exception type, like raise value error invalid value. Raising exceptions allows you to control the flow of your program and handle errors in a more specific and meaningful way. By raising an exception, you can signal to the calling code that something went wrong and provide information about the error. This can be particularly useful when writing functions or methods that need to communicate errors to the caller. When an exception is raised, the program will stop executing the current block of code and start looking for an exception handler that can handle the raised exception. If no suitable exception handler is found, the program will terminate and display a traceback message that shows the sequence of function calls that led to the exception. Let's consider an example to understand how raising exceptions works in practice. Suppose you are writing a function that calculates the area of a rectangle. However, you want to ensure that the width and height of the rectangle are positive numbers. If either of the dimensions is negative or 0, you want to raise a value error exception. Def calculate _rectangle _area width, height. If width less than equals 0 or height less than equals 0. Raise value error invalid dimensions, width and height must be positive numbers, return width * height. In the above code, we check if either the width or height is less than or equal to 0. If this condition is true, we raise a value error exception with an appropriate error message. Otherwise, we calculate and return the area of the rectangle. Now, let's see how this function behaves when called with different inputs. Print calculate underscore rectangle underscore area 5, 10 hash output 50. Print calculate underscore rectangle underscore area minus 5, 10 hash raises value error. Invalid dimensions, width and height must be positive numbers. In the first call, the function is called with valid dimensions, and it returns the correct area of the rectangle. However, in the second call, the function is called with a negative width, which violates the condition we set. As a result, a value error exception is raised, and the program terminates with an error message. Raising exceptions not only allows you to handle errors but also provides a way to communicate the cause of the error to the caller. By including a descriptive error message, you can provide valuable information about what went wrong and how to fix it. This can be especially helpful when debugging or maintaining code. It's important to choose the appropriate exception type when raising exceptions. Python provides a wide range of built-in exception types that cover various types of errors. By selecting the most suitable exception type, you can provide more specific information about the error and make it easier for the caller to handle the exception. In addition to the built-in exception types, you can also create your own custom exception classes by subclassing the exception class. This allows you to define your own exception hierarchy and add additional functionality to your exceptions if needed. When raising exceptions, it's good practice to include informative error messages that explain the cause of the exception. This helps in debugging and makes it easier for others, including yourself, to understand the error when reading the code later. In summary, raising exceptions in Python allows you to handle errors in exceptional situations in a controlled and meaningful way. By raising an exception, you can signal that something unexpected or erroneous has occurred and provide information about the error. This helps in debugging, maintaining, and communicating errors in your code. Remember to choose the appropriate exception type and include descriptive error messages to make your exceptions more informative and helpful. 6.4 Exception Handling Best Practices. Exception handling is an essential aspect of writing robust and reliable code in Python. It allows you to gracefully handle errors and unexpected situations that may occur during the execution of your program. In this section, we will discuss some best practices for exception handling in Python. 1. Be specific with exception handling. When handling exceptions, it is important to be as specific as possible. Instead of using a generic except block, it is recommended to catch specific exceptions that you expect might occur. This helps in better understanding and debugging of the code. For example, try hash some code that may raise an exception except value error. Hash handle the value error exception except file not found error. Hash handle the file not found error exception except exception is E. Hash handle any other exceptions. By catching specific exceptions, you can provide targeted error handling for each type of exception, improving the overall reliability of your code. 2. Use multiple except blocks. In situations where you need to handle multiple exceptions, it is advisable to use multiple except blocks. This allows you to provide different error handling logic for each exception. For example, try hash some code that may raise an exception except value error. Hash handle the value error exception except file not found error. Hash handle the file not found error exception except exception is E. Hash handle any other exceptions. Using multiple except blocks makes your code more readable and maintainable, as it clearly separates the error handling logic for each exception. 3. Avoid bare except blocks. A bare except block, which catches all exceptions without specifying any particular exception, should be avoided. It makes it difficult to identify and debug specific errors in your code. Instead, catch specific exceptions or use a generic except block at the end to handle any unexpected exceptions. For example, try hash some code that may raise an exception except value error. Hash handle the value error exception except file not found error. Hash handle the file not found error exception except exception is E. Hash handle any other exceptions. By avoiding bare except blocks, you ensure that your code is more robust and easier to maintain. 4. Use finally block for cleanup. The finally block is used to define code that will be executed regardless of whether an exception occurs or not. It is typically used for cleanup operations, such as closing files or releasing resources. For example, try hash some code that may raise an exception except value error. Hash handle the value error exception except file not found error. Hash handle the file not found error exception except exception is E. Hash handle any other exceptions finally. Hash cleanup code. By using the finally block, you can ensure that important cleanup operations are always performed, even if an exception occurs. 5. Re-raise exceptions when necessary. In some cases, you may need to catch an exception, perform some additional operations, and then re-raise the exception. This can be done using the raise statement without any arguments. For example, try hash some code that may raise an exception except value error. Hash handle the value error exception hash perform additional operations raise. Re-raising exceptions allows you to propagate the exception to a higher level of the code hierarchy, where it can be handled appropriately. 6. Use custom exceptions when appropriate. Python allows you to define custom exceptions by creating a new class that inherits from the built-in exception class. Custom exceptions can be useful when you want to raise and handle specific types of errors in your code. For example, class custom exception, exception. Pass. Try. Hash some code that may raise a custom exception except custom exception. Hash handle the custom exception. By using custom exceptions, you can provide more meaningful error messages and improve the clarity of your code. 7. Log exceptions. Logging exceptions is an important practice for debugging and monitoring your code. By logging exceptions, you can track the occurrence of errors and gather valuable information for troubleshooting. Python provides the logging module, which can be used to log exceptions along with other relevant details. For example, import logging. Try. Hash some code that may raise an exception except exception is E. Hash log the exception logging. Exception, an error occurred. By logging exceptions, you can easily identify and analyze errors in your code, leading to more effective debugging and maintenance. 8. Test exception handling. Testing exception handling is crucial to ensure that your code behaves as expected in different error scenarios. Write test cases that intentionally raise exceptions and verify that the exceptions are handled correctly. This helps in identifying any issues or gaps in your exception handling logic. Use testing frameworks like Unitest or Python to automate the testing process and make it more efficient. In conclusion, following these exception handling best practices will help you write more reliable and maintainable Python code. By being specific with exception handling, using multiple except blocks, avoiding bare except blocks, using the finally block for cleanup, re-raising exceptions when necessary, using custom exceptions, logging exceptions, and testing exception handling, you can ensure that your code gracefully handles errors and unexpected situations. 7. File handling. 7.1 Reading and writing files. In Python, file handling is an essential aspect of programming. It allows you to read data from files, write data to files, and manipulate files in various ways. In this section, we will explore how to read and write files using Python. Opening a file. Before we can read or write data to a file, we need to open it. Python provides a built-in function called open that allows us to open a file. The open function takes two parameters, the file name and the mode in which we want to open the file. The mode parameter specifies whether we want to read from the file, write to the file, or both. Here are some of the most commonly used modes. R. Read mode. This is the default mode. It allows us to read data from the file. W. Write mode. This mode allows us to write data to the file. If the file already exists, it will be overwritten. If the file does not exist, a new file will be created. Append mode. This mode allows us to append data to an existing file. If the file does not exist, a new file will be created. X. Exclusive creation mode. This mode creates a new file but raises an error if the file already exists. B. Binary mode. This mode is used for reading or writing binary data, such as images or audio files. T. Text mode. This is the default mode and is used for reading or writing text files. To open a file, we can use the following syntax. File equals open filename, mode, reading a file. Once we have opened a file in read mode, we can read its contents using various methods. The most common method is the read method, which reads the entire contents of the file as a string. Here's an example. File equals open example.txt, r content equals file, read print content file, close. In the example above, we open the file named example.txt in read mode. We then use the read method to read the contents of the file and store it in the content variable. Finally, we print the contents and close the file using the close method. Apart from the read method, there are other methods available for reading files. Readline, this method reads a single line from the file. Readlines, this method reads all the lines from the file and returns them as a list. Writing to a file. To write data to a file, we need to open the file in write mode or append mode. In write mode, if the file already exists, its contents will be overwritten. In append mode, the new data will be added to the end of the file. Here's an example of writing data to a file. File equals open example.txt, w, file, write, hello, world. File, close. In the example above, we open the file named example.txt in write mode. We then use the write method to write the string, hello, world, to the file. Finally, we close the file using the close method. Apart from the write method, there are other methods available for writing to files. Write lines, this method writes a list of strings to the file. Closing a file. After we have finished reading or writing a file, it is important to close the file using the close method. Closing a file ensures that any changes made to the file are saved and frees up system resources. File equals open example.txt, r hash perform file operations file, close using the with statement. Python provides a more convenient way to handle file operations using the with statement. The with statement automatically takes care of closing the file, even if an exception occurs. Here's an example. With open example.txt, r as file. Content equals file, read print content. In the example above, we use the with statement to open the file. Inside the with block, we can perform any file operations. Once we exit the with block, the file is automatically closed. Using the with statement is considered a best practice for file handling in Python. Error handling. When working with files, it is important to handle potential errors that may occur. For example, if a file does not exist or if we do not have the necessary permissions to access a file, an error will be raised. To handle such errors, we can use a try except block. The try block contains the code that may raise an error, and the except block handles the error if it occurs. Here's an example. Try. File equals open example.txt, r content equals file, read print content file, close. Except file not found error. Print file not found, except permission error. Print permission denied. In the example above, we try to open the file, example.txt, and read its contents. If the file is not found, a file not found error is raised, and the corresponding error message is printed. If we do not have the necessary permissions to access the file, a permission error is raised, and the corresponding error message is printed. By handling errors gracefully, we can ensure that our program does not crash unexpectedly when working with files. Conclusion. In this section, we learned how to read and write files in Python. We explored different file modes, methods for reading and writing files, and best practices for file handling. File handling is an essential skill for any Python programmer, as it allows us to work with external data and persist information across program executions. 7.2 Working with CSV files. CSV, separated values, is a popular file format used for storing tabular data. It is widely used in various fields such as data analysis, data science, and database management. Python provides built-in libraries that make it easy to work with CSV files and perform operations like reading, writing, and manipulating data. Reading CSV files. To read data from a CSV file, you can use the CSV module in Python. The CSV module provides a reader object that allows you to iterate over the rows in a CSV file. Here's an example of how to read data from a CSV file. Import CSV. With open data.csv, r as file. CSV_reader equals CSV. Reader file for row in CSV_reader, print row. In the above code, we first import the CSV module. Then, we open the CSV file using the open function and specify the file mode as r for reading. We create a CSV_reader object using the reader function from the CSV module. Finally, we iterate over the rows in the CSV file using a for loop and print each row. Writing CSV files. To write data to a CSV file, you can use the CSV module's writer object. The writer object allows you to write rows of data to a CSV file. Here's an example of how to write data to a CSV file. Import CSV. Data equals name, age, country, John, 25 feet, USA, Alice, 30 feet, Canada, Bob, 35 feet, UK. With open data.csv, w, new line equals, as file. CSV_writer equals CSV, writer file CSV_writer, writer rows data. In the above code, we first import the CSV module. Then, we define the data that we want to write to the CSV file as a list of lists. Each inner list represents a row of data. We open the CSV file using the open function and specify the file mode as w for writing. We create a CSV_writer object using the writer function from the CSV module. Finally, we use the writer rows method to write the data to the CSV file. Manipulating CSV data. Python provides various methods and functions to manipulate CSV data. For example, you can use the CSV reader object's next method to skip the header row when reading a CSV file. Here's an example. Import CSV. With open data.csv, r as file. CSV_reader equals CSV. Reader file header equals next CSV_reader for row in CSV_reader, print row. In the above code, we use the next method to skip the header row and store it in the header variable. Then, we iterate over the remaining rows in the CSV file and print each row. You can also use the CSV dict_reader class to read a CSV file as a dictionary. Each row in the CSV file will be represented as a dictionary, where the keys are the column names and the values are the corresponding values in the row. Here's an example. Import CSV. With open data.csv, r as file. CSV_reader equals CSV, dict_reader file for row in CSV_reader. Print row name, row age, row country. In the above code, we use the CSV dict_reader class to read the CSV file. We can access the values in each row using the column names as keys in the dictionary. Conclusion. Working with CSV files is a common task in data processing and analysis. Python provides a convenient and efficient way to read, write, and manipulate CSV data using the built-in CSV module. In this section, you learned how to read and write CSV files, skip header rows, and work with CSV data as dictionaries. With this knowledge, you can now confidently handle CSV files in your Python programs. 7.3 Working with JSON files. JSON JavaScript Object Notation is a popular data interchange format that is widely used for storing and transmitting data. It is a lightweight and human-readable format that is easy to understand and work with. In Python, the JSON module provides functions for working with JSON files. 7.3.1 JSON Basics. JSON is based on key-value pairs and supports various data types, including strings, numbers, booleans, arrays, and objects. The basic structure of a JSON file consists of curly braces that enclose key-value pairs. Keys are always strings, and values can be any valid JSON data type. Here's an example of a simple JSON file. Name, John Doe, age, 30, is _student, false, subjects, math, science, English, address. Street, 123 Main Street, City, New York, State, NY. In this example, the JSON file represents a person's information. The name, age, and his _student keys have string, number, and Boolean values, respectively. The subject's key has an array value containing multiple strings. The address key has an object value with nested key value pairs. 7.3.2 Reading JSON files. To read data from a JSON file in Python, you can use the JSON load function from the JSON module. This function takes a file object as input and returns a Python object representing the JSON data. Here's an example of reading data from a JSON file. Import JSON. Open the JSON file with open data JSON as file. Load the JSON data equals JSON load file. Access the data. Print data name output John Doe, print data age output 30, print data subjects output math, science, English. In this example, we open the data JSON file using the open function and then pass the file object to the JSON load function. The returned JSON data is stored in the data variable, which we can access using the keys. 7.3.3 Writing JSON files. To write data to a JSON file in Python, you can use the JSON dump function from the JSON module. This function takes a Python object and a file object as input and writes the JSON representation of the object to the file. Here's an example of writing data to a JSON file. Import JSON. Create a Python object data equals name, John Doe, age, 30, is _student, false, subjects, math, science, English, address. Street, 123 Main Street, City, New York, State, NY. Open the JSON file in write mode with open data JSON W as file. Write the JSON data JSON dump data file. In this example, we create a Python object data representing the JSON data. We then open the data JSON file in write mode using the open function and pass the file object to the JSON dump function along with the data object. The JSON representation of the data is written to the file. 7.3.4 Modifying JSON files. To modify data in a JSON file, you need to read the file, make the necessary changes to the data, and then write the modified data back to the file. This can be done by combining the techniques discussed earlier for reading and writing JSON files. Here's an example of modifying data in a JSON file. Import JSON. Open the JSON file with open data JSON as file. Load the JSON data equals JSON load file. Modify the data age equals 31. Data subjects append history. Write the modified data back to the file with open data JSON W as file. JSON dump data file. In this example, we first read the JSON data from the data JSON file. We then modify the age key and append a new subject to the subjects array. Finally, we write the modified data back to the file. 7.3.5 Handling errors. When working with JSON files, it's important to handle errors that may occur during reading or writing operations. The JSON module provides the JSON JS ondecode error and JSON JS onencode error exceptions for handling decoding and encoding errors, respectively. Here's an example of error handling when reading a JSON file. Import JSON. Try. With open data JSON as file, data equals JSON load file. Accept JSON JS ondecode error. Print error, invalid JSON format, except file not found error. Print error, file not found. In this example, we use a try except block to catch any JS ondecode error that may occur when loading the JSON data. We also catch the file not found error in case the file does not exist. Conclusion. Working with JSON files in Python is straightforward using the JSON module. You can easily read, write, and modify JSON data using the provided functions. JSON is a versatile format that is widely used for data storage and exchange, making it an essential skill for any Python programmer. 7.4 Working with XML files. XML, Extensible Markup Language, is a popular markup language used for storing and transporting data. It provides a structured way to represent data in a hierarchical format. In this section, we will explore how to work with XML files using Python. 7.4.1 Introduction to XML. XML is a text-based format that uses tags to define elements and their attributes. It is similar to HTML but is more flexible and customizable. XML files are commonly used for data exchange between different systems and applications. An XML file consists of a prologue, which includes the XML version and encoding, followed by the root element. The root element can contain child elements, which can in turn have their own child elements. Each element can have attributes that provide additional information about the element. 7.4.2 Parsing XML. To work with XML files in Python, we need to parse the XML data and convert it into a usable format. Python provides several libraries for parsing XML, including the built-in XML module and third-party libraries like LXML and XML, eTree, Elementary. The XML, eTree, Elementary module is part of the Python standard library and provides a simple and efficient way to parse XML data. Here's an example of how to parse an XML file using Elementary. Import XML, eTree, Elementary as ET. Hash parse the XML file tree equals ET, parse data.xml. Hash get the root element root equals tree, get root. Hash access elements and attributes for child in root. Print child.tag, child, attrib. In the above example, we first import the XML, eTree, Elementary module and then use the ET, parse function to parse the XML file. We can then access the root element using the getRoot method. Once we have the root element, we can iterate over its child elements using a for loop. Each child element has a tag attribute that represents the element name and an attrib attribute that contains a dictionary of element attributes. 7.4.3 Accessing XML data. After parsing an XML file, we can access the data stored in the XML elements and attributes. The element objects returned by Elementary provide several methods and properties for accessing XML data. To access the text content of an element, we can use the text property. For example, import XML, eTree, Elementary as ET. Hash parse the XML file tree equals ET, parse data.xml, root equals tree, get root. Hash access the text content of an element for child in root. Print child.tag, child, text. In the above example, we use the text property to access the text content of each child element. We can also access the attributes of an element using the attrib property. For example, import XML, eTree, Elementary as ET. Hash parse the XML file tree equals ET, parse data.xml, root equals tree, get root. Hash access the attributes of an element for child in root. Print child.tag, child, attrib. In the above example, we use the attrib property to access the attributes of each child element. 7.4.4 Modifying XML data. In addition to accessing XML data, we can also modify the data and write it back to an XML file. The element objects returned by Elementary provide methods for adding, modifying, and deleting elements and attributes. To add a new element, we can use the element constructor and the append method. For example, import XML, eTree, Elementary as ET. Hash parse the XML file tree equals ET, parse data.xml, root equals tree, get root. Hash add a new element new underscore element equals ET, element new underscore element, text equals, new element content, root, append new underscore element. Hash write the modified XML back to a file tree, write modified underscore data.xml. In the above example, we create a new element using the element constructor and set its text content. We then append the new element to the root element using the append method. Finally, we use the write method to write the modified XML back to a file. To modify the text content of an element, we can simply assign a new value to the text property. To modify the attributes of an element, we can use the set method. For example, import XML, eTree, Elementary as ET. Hash parse the XML file tree equals ET, parse data.xml, root equals tree, get root. Hash modify the text content of an element for child in root. Child, text equals, new text content. Hash modify the attributes of an element for child in root. Child.set attribute underscore name, new underscore attribute underscore value. Hash write the modified XML back to a file tree, write modified underscore data.xml. In the above example, we use a for loop to iterate over the child elements of the root element. We then modify the text content of each child element by assigning a new value to the text property. We also modify the attributes of each child element using the set method. Finally, we write the modified XML back to a file. 7.4.5 Conclusion. Working with XML files in Python is straightforward using the built-in XML module or third-party libraries like LXML and XML, eTree, Elementary. We can parse XML data, access the elements and attributes, and modify the data as needed. XML is a widely used format for data exchange, and being able to work with XML files is a valuable skill for any Python programmer. 8. Regular expressions. 8.1 Pattern matching. Pattern matching is a powerful technique used in programming to search for specific patterns within a given text or string. In Python, pattern matching is made possible through the use of regular expressions, also known as regex. Regular expressions provide a concise and flexible way to match and manipulate strings based on specific patterns. What are regular expressions? A regular expression is a sequence of characters that defines a search pattern. It consists of a combination of literal characters and special characters, which have special meanings within the regular expression syntax. Regular expressions can be used to perform various operations such as searching, matching, and replacing strings. Creating a regular expression. In Python, regular expressions are supported by the re module. To use regular expressions, you need to import the re module into your Python script. Once imported, you can create a regular expression pattern by using the re compile function. This function takes a string as input and returns a regular expression object. Here's an example of creating a regular expression pattern to match a specific word. Import re pattern equals re compile r hello. In the above example, the regular expression pattern r hello is created using the re compile function. The r before the string indicates that it is a raw string, which means that backslashes are treated as literal characters and not as escape characters. Matching patterns. Once you have created a regular expression pattern, you can use it to search for matches within a given text or string. The re module provides several functions for pattern matching, such as match, search, find all, and finditer. The match function is used to determine if the pattern matches at the beginning of the string. It returns a match object if there is a match, or none if there is no match. Import re pattern equals re compile r hello text equals hello world. Match equals pattern match text. If match, print pattern matched, else print pattern not found. In the above example, the match function is used to check if the pattern r hello matches at the beginning of the string hello world. Since the pattern matches, the output will be pattern matched. The search function is used to search for the pattern anywhere within the string. It returns a match object if there is a match, or none if there is no match. Import re pattern equals re compile r world text equals hello world. Match equals pattern search text. If match, print pattern found, else print pattern not found. In the above example, the search function is used to search for the pattern r world within the string hello world. Since the pattern is found, the output will be pattern found. The find all function is used to find all occurrences of the pattern within the string. It returns a list of all matches found. Import re pattern equals re compile r d plus text equals I have 3 apples and 5 oranges. Matches equals pattern find all text. Print matches. In the above example, the find all function is used to find all occurrences of one or more digits within the string I have 3 apples and 5 oranges. The output will be 3 feet, 5 feet as it matches the pattern d plus, which represents one or more digits. The finditer function is similar to find all, but it returns an iterator of match objects instead of a list. Import re pattern equals re compile r d plus text equals I have 3 apples and 5 oranges. Matches equals pattern finditer text. For match in matches, print match group. In the above example, the finditer function is used to find all occurrences of one or more digits within the string I have 3 apples and 5 oranges. The match group method is used to retrieve the matched string from each match object. The output will be 3 5. Special characters in regular expressions. Regular expressions use special characters to represent different types of patterns. Here are some commonly used special characters. Dot matches any character except a newline. Caret caret matches the start of a string. Dollar dollar matches the end of a string. Asterisk matches 0 or more occurrences of the preceding character. Plus plus matches 1 or more occurrences of the preceding character. Question mark matches 0 or 1 occurrence of the preceding character. Square brackets matches any single character within the brackets. Parentheses groups multiple characters together. These are just a few examples of the special characters used in regular expressions. The re module provides a comprehensive list of special characters and their meanings in the Python documentation. Conclusion. Pattern matching is a powerful technique that allows you to search for specific patterns within a given text or string. In Python, regular expressions provide a flexible and concise way to perform pattern matching operations. By using the re module and its functions, you can create regular expression patterns, search for matches, and perform various operations on strings. Regular expressions are widely used in text processing, data validation, and web scraping, making them an essential tool for any Python programmer. 8.2 Matching and searching. In the previous section, we learned about pattern matching using regular expressions. We saw how to define patterns using metacharacters and character classes. Now, let's explore how we can use regular expressions to perform matching and searching operations in Python. The match function. The match function is used to determine if the regular expression pattern matches at the beginning of a string. It returns a match object if there is a match, or none if there is no match. Here's the syntax for using the match function. Import re. Pattern equals r, abc, string equals, abcdef. Match underscore object equals re. Match pattern, string. In the example above, we import the re module and define a pattern abc and a string abcdef. We then call the match function with the pattern and string as arguments. The match underscore object will contain the match if there is one, or none if there is no match. The search function. The search function is similar to the match function, but it searches for a match anywhere in the string, not just at the beginning. It returns a match object if there is a match, or none if there is no match. Here's an example. Import re. Pattern equals r, abc, string equals, diff abc. Match underscore object equals re. Search pattern, string. In this example, the pattern abc is searched for in the string diff abc. The search function will find a match because abc is present in the string. The match underscore object will contain the match. The findAll function. The findAll function is used to find all occurrences of a pattern in a string. It returns a list of all matches found. Here's how to use it. Import re. Pattern equals r, abc, string equals, abc abc abc. Matches equals re. FindAll pattern, string. In this example, the pattern abc is searched for in the string abc abc abc. Since abc appears 3 times in the string, the findAll function will return a list with 3 elements, each containing a match. The findIter function. The findIter function is similar to the findAll function, but it returns an iterator instead of a list. Each element of the iterator is a match object. Here's an example. Import re. Pattern equals r, abc, string equals, abc abc abc. Matches equals re. FindIter pattern, string. For match in matches. Print match. In this example, the findIter function is used to find all occurrences of the pattern abc in the string abc abc abc. The matches object is an iterator, and we can iterate over it using a for loop. Each element of the iterator is a match object, which we can use to access information about the match. The full match function. The full match function is used to determine if the entire string matches the pattern. It returns a match object if there is a match, or none if there is no match. Here's an example. Import re. Pattern equals r, abc, string equals, abc. Match underscore object equals re. Full match pattern, string. In this example, the pattern abc is compared to the string abc using the full match function. Since the entire string matches the pattern, the match underscore object will contain the match. The match versus search functions. The match function only checks if the pattern matches at the beginning of the string, while the search function searches for a match anywhere in the string. If you want to find a pattern at the beginning of a string, use match. If you want to find a pattern anywhere in the string, use search. Conclusion. In this section, we explored the various functions provided by the re module in Python for matching and searching using regular expressions. We learned how to use the matched search findAll findIter and full match functions to perform different types of matching and searching operations. Understanding these functions will allow you to effectively use regular expressions to manipulate and extract information from strings in Python. 8.3 Replacing and splitting. In Python, the re module provides a powerful way to work with regular expressions. Regular expressions allow you to search, replace, and split strings based on specific patterns. In this section, we will explore how to use regular expressions to replace and split strings. Replacing strings. The re module provides the sub function, which allows you to replace occurrences of a pattern in a string with a specified replacement. The basic syntax of the sub function is as follows. Re.sub pattern, replacement, string. Here, pattern is the regular expression pattern to search for, replacement is the string to replace the matched pattern, and string is the input string. Let's look at an example to understand how to use the sub function. Suppose we have a string that contains multiple occurrences of the word apple, and we want to replace all occurrences with the word banana. We can achieve this using the sub function as follows. Import re. String equals, I have an apple, and she has an apple too. New underscore string equals re.sub apple, banana, string print new underscore string. Output. I have an banana, and she has an banana too. In the above example, the sub function replaces all occurrences of the word apple with the word banana in the input string. The sub function also supports using back references in the replacement string. Back references allow you to refer to captured groups in the pattern. To use a back reference, you can use that number syntax, where number is the index of the captured group. Let's see an example. Import re. String equals John Doe, Jane Smith, and Mark Johnson. New underscore string equals re.sub r. W plus s w plus r. 2, 1 inch, string print new underscore string. Output. Doe, John Smith, Jane, and Johnson, Mark. In the above example, the pattern W plus SW plus captures two words separated by a space. The replacement string R, 2, 1, uses back references to swap the order of the captured words and add a comma between them. Splitting strings. The RE module also provides the split function, which allows you to split a string based on a specified pattern. The basic syntax of the split function is as follows. RE, split pattern, string. Here, pattern is the regular expression pattern to split the string, and string is the input string. Let's look at an example to understand how to use the split function. Suppose we have a string that contains multiple words separated by commas and spaces, and we want to split the string into a list of words. We can achieve this using the split function as follows. Import RE. String equals, apple, banana, orange, mango, word underscore list equals RE. Split R, S, string print word underscore list. Output. Apple, banana, orange, mango. In the above example, the split function splits the input string at each occurrence of a comma followed by a space, S, resulting in a list of words. The split function also supports using capturing groups in the pattern. When using capturing groups, the matched groups will also be included in the resulting list. Let's see an example. Import RE. String equals, John Doe, Jane Smith, Mark Johnson, name underscore list equals RE. Split R, SW plus string print name underscore list. Output. John Doe, Jane Smith, Mark Johnson. In the above example, the pattern, SW plus captures a comma followed by a space in a word. The resulting list includes the captured words along with the split parts. Conclusion. In this section, we explored how to use regular expressions in Python to replace and split strings. The RE module provides the sub function for replacing occurrences of a pattern in a string, and the split function for splitting a string based on a pattern. Regular expressions are a powerful tool for manipulating and extracting information from strings, and mastering them can greatly enhance your Python programming skills. 8.4 Regular Expression Best Practices. Regular expressions are powerful tools for pattern matching and manipulating text in Python. However, they can also be complex and difficult to maintain if not used properly. In this section, we will discuss some best practices for working with regular expressions in Python. 1. Understand the basics. Before diving into regular expressions, it is important to have a solid understanding of the basic syntax and concepts. Regular expressions consist of a combination of literal characters and special characters called metacharacters. Metacharacters have special meanings and are used to define patterns. Some common metacharacters include: dot matches any character except a newline. Asterisk matches 0 or more occurrences of the preceding character or group. Plus plus matches 1 or more occurrences of the preceding character or group. Question mark matches 0 or 1 occurrence of the preceding character or group. Square brackets matches any single character within the brackets. Parentheses groups characters together. Understanding these basic metacharacters will help you construct more complex regular expressions. 2. Use raw strings. When working with regular expressions in Python, it is recommended to use raw strings by prefixing the string with R. Raw strings treat backslashes as literal characters, which is important when dealing with regular expression patterns that contain backslashes. For example, pattern equals RD plus. Hash matches 1 or more digits using raw strings ensures that the regular expression pattern is interpreted correctly. 3. Compile regular expressions. In Python, regular expressions can be compiled into pattern objects using the compile function. Compiling regular expressions can improve performance, especially if you need to use the same pattern multiple times. By compiling the pattern, you avoid the overhead of reparsing the regular expression each time it is used. Here's an example. Import RE. Pattern equals RE. Compile RD plus. Hash compile the regular expression pattern result equals pattern. Find all I have 10 apples and 5 oranges. Hash use the compiled pattern for. Use anchors. Anchors are special characters that match the position of a string, rather than matching any specific character. Anchors are useful for ensuring that a pattern matches at a specific location within a string. The two most commonly used anchors are: caret matches the start of a string. $$ matches the end of a string. For example, the pattern $d plus will match any sequence of digits at the beginning of a string. 5. Be mindful of greedy matching. By default, regular expressions in Python use greedy matching, which means they will match as much as possible. This can lead to unexpected results if you are not careful. To make a quantifier non-greedy, you can append a after it. For example, the pattern will match as little as possible. 6. Use character classes. Character classes allow you to match a set of characters. They are defined using square brackets and can include ranges of characters, as well as special character classes. For example, the pattern AZAZ will match any uppercase or lowercase letter. 7. Test and debug regular expressions. Regular expressions can be complex, and it is important to test and debug them to ensure they are working as expected. Python provides the debug flag, which can be used to print debugging information about the regular expression. Additionally, there are online tools and libraries available that can help you test and visualize regular expressions. 8. Document your regular expressions. Regular expressions can be difficult to understand, especially if they are complex or used in a non-trivial way. It is important to document your regular expressions to make them more maintainable. You can use comments to explain the purpose and logic of the regular expression, as well as provide examples of the expected input and output. 9. Consider performance. Regular expressions can be computationally expensive, especially for large input strings or complex patterns. If performance is a concern, consider optimizing your regular expressions by using more specific patterns or by using alternative string manipulation techniques. 10. Use libraries for complex tasks. While regular expressions are powerful, they may not always be the best tool for every task. For complex text manipulation tasks, consider using specialized libraries or modules that provide higher-level abstractions. These libraries can simplify the code and make it easier to understand and maintain. By following these best practices, you can effectively use regular expressions in your Python programs. Regular expressions are a valuable tool for text processing and can greatly enhance your ability to manipulate and extract information from strings. 9. Database connectivity. 9.1 Introduction to databases. In today's digital age, data is everywhere. From small businesses to large corporations, data plays a crucial role in decision-making and operations. As a Python programmer, it is essential to understand how to work with databases to store, retrieve, and manipulate data efficiently. In this section, we will explore the fundamentals of databases and how to connect to them using Python. What is a database? A database is a structured collection of data that is organized and stored in a way that allows for efficient retrieval, modification, and deletion. It provides a systematic approach to managing data, ensuring data integrity, and enabling multiple users to access and manipulate data simultaneously. Databases are used to store various types of information, such as customer details, product inventory, financial records, and much more. They are designed to handle large volumes of data and provide mechanisms for querying and manipulating that data. Types of databases. There are several types of databases available, each with its own strengths and use cases. The most common types of databases are relational databases. Relational databases store data in tables with predefined relationships between them. They use structured query language, SQL, to interact with the data. Examples of popular relational databases include MySQL, PostgreSQL, and Oracle. NoSQL databases. NoSQL databases are non-relational databases that provide a flexible schema and can handle unstructured and semi-structured data. They are suitable for handling large amounts of data and are often used in big data and real-time applications. Examples of NoSQL databases include MongoDB, Cassandra, and Redis. Object-oriented databases. Object-oriented databases store data in the form of objects, similar to how objects are used in object-oriented programming. They are designed to work well with object-oriented programming languages and provide features like inheritance and encapsulation. Examples of object-oriented databases include DB4O and ObjectDB. Graph databases. Graph databases store data in a graph structure, where nodes represent entities, and edges represent relationships between them. They are particularly useful for handling complex relationships and querying connected data. Examples of graph databases include Neo4j and Amazon Neptune. Python database APIs. Python provides several database APIs, application programming interfaces, that allow us to interact with different types of databases. These APIs provide a set of functions and methods to connect to databases, execute queries, and retrieve results. Some popular Python database APIs include PythonDB API. PythonDB API is a standard interface for connecting to relational databases using Python. It provides a consistent API across different database drivers, allowing developers to write database-agnostic code. Examples of PythonDB API modules include SQLite 3, PsychoPG2 for PostgreSQL, and MySQL Connector Python for MySQL. MongoDB driver. MongoDB provides an official Python driver called PyMongo for interacting with MongoDB databases. It allows us to connect to a MongoDB server, insert and retrieve documents, and perform various operations on the data. Redis PY. Redis is an in-memory data structure store that can be used as a database, cache, or message broker. The Redis PY library provides a Python interface to interact with Redis databases, allowing us to store and retrieve data using various data structures like strings, lists, sets, and more. Neo4j driver. Neo4j is a popular graph database, and it provides an official Python driver called Neo4j for interacting with Neo4j databases. The driver allows us to connect to a Neo4j server, create nodes and relationships, and perform graph-based queries. Connecting to databases. To connect to a database using Python, we need to install the appropriate database driver or library and import it into our Python script. The specific steps may vary depending on the database and the Python database API being used. Once the driver or library is installed, we can establish a connection to the database by providing the necessary connection parameters, such as the host, port, username, password, and database name. After establishing the connection, we can execute SQL queries or other database operations. Here's an example of connecting to a MySQL database using the MySQL connector Python library. Import MySQL connector. Hash establish a connection to the MySQL database connection equals MySQL connector connect. Host equals localhost, user equals username, password equals password, database equals my database. Hash perform database operations. Hash close the connection close. In the above example, we import the MySQL connector module, establish a connection to the MySQL database by providing the necessary connection parameters, and then perform the desired database operations. Finally, we close the connection to release any resources held by the database server. Conclusion. Understanding databases and how to work with them is a crucial skill for any Python programmer. In this section, we explored the basics of databases, including the different types of databases and the Python database APIs available. We also learned how to connect to databases using Python and execute database operations. With this knowledge, you can now start building applications that interact with databases and leverage the power of data in your Python projects. 9.2 Connecting to databases. In today's digital age, data is the backbone of many applications and systems. Whether it's storing user information, managing inventory, or analyzing trends, databases play a crucial role in organizing and retrieving data efficiently. Python, being a versatile programming language, provides several libraries and modules to connect and interact with databases seamlessly. Understanding databases. Before we dive into connecting to databases using Python, let's briefly understand what databases are and how they work. A database is a structured collection of data that is organized and stored in a way that allows for efficient retrieval, modification, and deletion of data. Databases use a specific structure called a schema to define the organization and relationships between different types of data. There are various types of databases available, such as relational databases, NoSQL databases, and object-oriented databases. Relational databases, like MySQL, PostgreSQL, and SQLite, are the most commonly used type. They store data in tables with rows and columns, and the relationships between tables are defined using keys. Connecting to relational databases. Python provides several libraries to connect to relational databases. One of the most popular libraries is SQLite 3, which is included in the Python standard library. It allows you to connect to SQLite databases, which are lightweight and perfect for small to medium-sized applications. To connect to an SQLite database using SQLite 3, you need to import the library and establish a connection object. Here's an example. Import SQLite 3. Hash connect to the database con equals SQLite 3, connect my database, DB. In the above example, we import the SQLite 3 module and use the connect function to establish a connection to the database file named my database, DB. If the file doesn't exist, SQLite will create it for you. Once the connection is established, you can create a cursor object to execute SQL queries and interact with the database. Here's an example. Import SQLite 3. Hash connect to the database con equals SQLite 3, connect my database, DB. Hash create a cursor object cursor equals con, cursor. Hash execute a SQL query cursor, execute select asterisk from users. Hash fetch the results equals cursor, fetch all. Hash close the cursor and connection cursor, close. Con, close. In the above example, we create a cursor object using the cursor method of the connection object. We then execute a SQL query using the execute method of the cursor object. The fetchAll method retrieves all the rows returned by the query. Finally, we close the cursor and the connection using the close method. Connecting to other relational databases. Apart from SQLite, Python provides libraries to connect to other popular relational databases like MySQL, PostgreSQL, and Oracle. These libraries offer similar functionality to SQLite 3 but with slight differences in syntax and configuration. For MySQL, you can use the MySQL connector Python library, which provides a Python interface to MySQL databases. Here's an example of connecting to a MySQL database. Import MySQL connector. Hash connect to the database con equals MySQL connector, connect. Host equals localhost, user equals username, password equals password, database equals my database. In the above example, we import the MySQL connector module and use the connect function to establish a connection to the MySQL database. We provide the necessary connection details like the host, username, password, and database name. Similarly, for PostgreSQL, you can use the psycopg2 library, which is a PostgreSQL adapter for Python. Here's an example of connecting to a PostgreSQL database. Import psycopg2. Hash connect to the database con equals psycopg2, connect. Host equals localhost, user equals username, password equals password, database equals my database. In the above example, we import the psycopg2 module and use the connect function to establish a connection to the PostgreSQL database. We provide the necessary connection details like the host, username, password, and database name. Connecting to NoSQL databases. Python also provides libraries to connect to NoSQL databases like MongoDB, Redis, and Cassandra. These databases store data in a non-tabular format, making them suitable for handling large amounts of unstructured or semi-structured data. For MongoDB, you can use the PyMongo library, which is the official Python driver for MongoDB. Here's an example of connecting to a MongoDB database. From PyMongo import Mongo client. Hash connect to the database client equals Mongo client. Hash access a specific database DB equals client my database. In the above example, we import the Mongo client class from the PyMongo module and use it to establish a connection to the MongoDB server running on localhost at the default port 27017. We then access a specific database named myDatabase using the client myDatabase syntax. Connecting to other NoSQL databases like Redis and Cassandra follows a similar pattern, where you import the appropriate library and use the provided methods to establish a connection. Conclusion. Connecting to databases is a fundamental skill for any Python developer working with data-driven applications. Python provides a wide range of libraries and modules to connect to various types of databases, including relational databases like SQLite, MySQL, and PostgreSQL, as well as NoSQL databases like MongoDB, Redis, and Cassandra. By understanding the different libraries and their usage, you can effectively connect to databases and leverage the power of data in your Python applications. 9.3 Executing SQL Queries. In this section, we will explore how to execute SQL queries using Python. SQL, Structured Query Language, is a standard language for managing and manipulating relational databases. Python provides several libraries and modules that allow us to connect to databases and execute SQL queries. Connecting to a database. Before we can execute SQL queries, we need to establish a connection to the database. Python provides various libraries for connecting to different types of databases, such as SQLite, MySQL, PostgreSQL, and Oracle. To connect to a database, we need to install the appropriate database driver or connector for the database we are using. Each database has its own specific driver or connector that allows Python to communicate with it. Once we have installed the necessary driver or connector, we can use the connect function provided by the library to establish a connection to the database. The connect function takes the necessary parameters, such as the database name, username, password, and host, to establish the connection. Here is an example of connecting to a SQLite database using the SQLite 3 module. Import SQLite 3. Hash connect to the database con equals SQLite 3. Connect example. DB, executing SQL queries. Once we have established a connection to the database, we can execute SQL queries using the connection object. Python provides methods to execute different types of SQL queries, such as select, insert, update, and delete. To execute a SQL query, we need to create a cursor object using the cursor method provided by the connection object. The cursor object allows us to execute SQL queries and fetch the results. Here is an example of executing a select query to retrieve data from a table. Import SQLite 3. Hash connect to the database con equals SQLite 3. Connect example, DB. Hash create a cursor object cursor equals con, cursor. Hash execute a select query cursor. Execute select asterisk from employees. Hash fetch all the rows from the result set rows equals cursor, fetch all. Hash print the rows for row in rows. Print, row. Hash close the cursor and the connection cursor, close. Con, close. In the above example, we first establish a connection to the SQLite database. Then, we create a cursor object using the cursor method. We execute a select query using the execute method of the cursor object. The fetchAll method retrieves all the rows from the result set. Finally, we iterate over the rows and print them. Parameterized queries. When executing SQL queries, it is important to use parameterized queries to prevent SQL injection attacks and improve performance. Parameterized queries allow us to pass parameters to the SQL query separately, rather than concatenating them directly into the query string. Python provides support for parameterized queries using placeholders. Placeholders are represented by question marks. Or named placeholders, name. We can pass the values for the placeholders as a tuple or dictionary, respectively. Here is an example of executing a parameterized select query. Import SQLite 3. Hash connect to the database con equals SQLite 3. Connect example, DB. Hash create a cursor object cursor equals con, cursor. Hash execute a parameterized select query cursor. Execute select asterisk from employees where age greater than 30. Hash fetch all the rows from the result set rows equals cursor, fetch all. Hash print the rows for row in rows. Print, row. Hash close the cursor and the connection cursor, close. Con, close. In the above example, we use a placeholder in the SQL query and pass the value 30 as a parameter. The parameter value is passed as a tuple 30 to the execute method. Error handling. When executing SQL queries, it is important to handle any errors that may occur. Python provides exception handling mechanisms to catch and handle errors that occur during the execution of SQL queries. We can use a try except block to catch exceptions raised by the database library. Inside the try block, we execute the SQL query, and inside the except block, we handle any exceptions that occur. Here is an example of handling errors when executing a SQL query. Import SQLite 3. Hash connect to the database con equals SQLite 3. Connect example DB. Hash create a cursor object cursor equals con cursor. Try. Hash execute a SQL query cursor. Execute select asterisk from employees. Hash fetch all the rows from the result set rows equals cursor. Fetch all. Hash print the rows for row in rows. Print row. Except SQLite 3. Error is E. Hash handle the error print an error occurred E. Finally. Hash close the cursor and the connection cursor. Close. Con. Close. In the above example, we use a try except block to catch any exceptions that occur during the execution of the SQL query. If an exception occurs, we print an error message. Finally, we close the cursor and the connection in the finally block to ensure that they are properly closed, regardless of whether an exception occurred or not. Conclusion. In this section, we learned how to execute SQL queries using Python. We explored how to connect to a database, execute SQL queries, use parameterized queries, and handle errors. Understanding how to execute SQL queries in Python is essential for working with databases and performing data manipulation and retrieval tasks. 9.4 Working with result sets. When working with databases, it is common to retrieve data from the database using SQL queries. These queries return a result set, which is a collection of rows that match the query criteria. In this section, we will explore how to work with result sets in Python. Fetching rows. To retrieve rows from a result set, we need to execute a SQL query using the execute method of the database cursor. Once the query is executed, we can fetch the rows using various methods provided by the cursor object. The most common method to fetch rows is the fetchOwned method, which retrieves the next row from the result set. It returns a single row as a tuple or none if there are no more rows to fetch. Here's an example. Import SQLite 3. Hash connect to the database con equals SQLite 3. Connect my database, DB. Hash create a cursor object cursor equals con cursor. Hash execute a SQL query cursor. Execute select asterisk from employees. Hash fetch a single row equals cursor. FetchOwn. Hash print the row print row. Hash close the cursor and the connection cursor. Close. Con. Close. In the example above, we connect to a SQLite database, create a cursor object, execute a SQL query to select all rows from the employees table, fetch the first row using FetchOwn, and print the row. If we want to fetch multiple rows at once, we can use the fetchMany method. This method takes an optional parameter that specifies the number of rows to fetch. If no parameter is provided, it fetches the number of rows specified by the arraySize attribute of the cursor. Here's an example. Import SQLite 3. Hash connect to the database con equals SQLite 3. Connect my database, DB. Hash create a cursor object cursor equals con cursor. Hash execute a SQL query cursor. Execute select asterisk from employees. Hash fetch 3 rows equals cursor. FetchMany 3. Hash print the rows for row in rows. Print row. Hash close the cursor and the connection cursor. Close. Con. Close. In the example above, we fetch 3 rows from the result set using fetchMany and print each row. If we want to fetch all rows from the result set, we can use the fetchAll method. This method returns a list of tuples, where each tuple represents a row from the result set. Here's an example. Import SQLite 3. Hash connect to the database con equals SQLite 3. Connect my database, DB. Hash create a cursor object cursor equals con cursor. Hash execute a SQL query cursor. Execute select asterisk from employees. Hash fetch all rows equals cursor. Fetch all. Hash print the rows for row in rows. Print row. Hash close the cursor and the connection cursor. Close. Con. Close. In the example above, we fetch all rows from the result set using fetchAll and print each row. Working with columns. In addition to fetching rows, we can also work with individual columns from the result set. Each row in the result set is represented as a tuple, and we can access individual columns by their index. For example, let's say we have a result set with 3 columns, id, name, and salary. We can access the name column of each row using the index 1. Here's an example. Import SQLite 3. Hash connect to the database con equals SQLite 3. Connect my database, DB. Hash create a cursor object cursor equals con cursor. Hash execute a SQL query cursor. Execute select asterisk from employees. Hash fetch all rows equals cursor. Fetch all. Hash print the names for row in rows. Name equals row 1 print name. Hash close the cursor and the connection cursor, close. Close. In the example above, we access the name column of each row using the index 1 and print the names. Alternatively, we can also access columns by their names using the fetchOwned method. This method returns a row as a dictionary, where the keys are the column names and the values are the column values. Here's an example. Import SQLite3. Hash connect to the database con equals SQLite3, connect my database, DB. Hash create a cursor object cursor equals con, cursor. Hash execute a SQL query cursor, execute select asterisk from employees. Hash fetch a single row equals cursor, fetchOwn. Hash print the name equals row, name, print, name. Hash close the cursor and the connection cursor, close. Close. In the example above, we fetch a single row using fetchOwn and access the name column by its name. Summary. In this section, we learned how to work with result sets in Python. We explored different methods to fetch rows from a result set, such as fetchOwn, fetchMany, and fetchAll. We also learned how to access individual columns from the result set using their index or name. By understanding how to work with result sets, we can effectively retrieve and manipulate data from databases using Python. 10. Web scraping. 10.1 Introduction to web scraping. Web scraping is the process of extracting data from websites. It involves retrieving information from web pages and saving it for further analysis or use. Python provides powerful libraries and tools that make web scraping relatively easy and efficient. In this section, we will explore the basics of web scraping using Python. We will learn how to send HTTP requests to websites, parse HTML content, and extract the desired data. We will also discuss techniques for scraping dynamic websites that rely on JavaScript for rendering content. Understanding the basics. Before diving into web scraping, it is important to understand the structure of websites and how they deliver content. Websites are built using HTML, Hypertext Markup Language, which is a markup language that defines the structure and presentation of web pages. HTML consists of tags that enclose different elements such as headings, paragraphs, tables, and links. To scrape a website, we need to understand its HTML structure and identify the specific elements that contain the data we want to extract. This can be done by inspecting the HTML source code of the web page using browser developer tools. Sending HTTP requests. To retrieve the HTML content of a web page, we need to send an HTTP request to the website's server. Python provides the requests library, which makes it easy to send HTTP requests and handle the responses. Using the requests library, we can send a GET request to a URL and retrieve the HTML content of the web page. We can then parse this content to extract the desired data. The requests library also allows us to handle different types of requests such as post, put, and delete. Parsing HTML. Once we have retrieved the HTML content of a web page, we need to parse it to extract the relevant data. Python provides several libraries for parsing HTML, such as Beautiful Soup and LXML. Beautiful Soup is a popular library that allows us to parse HTML and XML documents. It provides a simple and intuitive interface for navigating and searching the parsed content. With Beautiful Soup, we can easily extract data from specific HTML elements, such as tables, lists, or divs, based on their tags, attributes, or class names. Extracting data. After parsing the HTML content, we can use Beautiful Soup to extract the desired data from the web page. We can access specific elements by their tags, attributes, or class names and retrieve their text or other attributes. For example, if we want to extract the titles of all the articles on a news website, we can use Beautiful Soup to find the HTML elements that contain the article titles and extract their text. We can then save this data for further analysis or use it in our own applications. Scraping dynamic websites. Some websites use JavaScript to dynamically load content or modify the HTML structure. Traditional web scraping techniques may not work on these websites because the HTML content is not fully rendered when we retrieve it. To scrape dynamic websites, we can use libraries such as Selenium or Scrapy. Selenium is a powerful tool that allows us to automate browser actions and interact with web pages. It can simulate user interactions, wait for JavaScript to execute, and retrieve the fully rendered HTML content. With Selenium, we can scrape websites that rely on JavaScript for rendering content. We can interact with elements on the web page, click buttons, fill forms, and retrieve the updated HTML content. Best practices. When performing web scraping, it is important to follow certain best practices to ensure the process is efficient, ethical, and respectful of the website's terms of service. Here are some best practices to keep in mind. Respect the website's terms of service and robots.txt file. Limit the number of requests to avoid overloading the server. Use appropriate headers and user agents to mimic a real user. Handle errors and exceptions gracefully. Be mindful of the website's bandwidth and server resources. Cache data to avoid unnecessary requests. Monitor and adjust scraping speed to avoid detection. By following these best practices, we can ensure that our web scraping activities are effective and responsible. In the next section, we will explore how to send HTTP requests using Python and retrieve the HTML content of web pages. We will also learn how to handle different types of requests and responses. 10.2 Sending HTTP requests. In today's digital age, the internet plays a crucial role in our lives. It provides us with a vast amount of information and resources. As a Python programmer, you may often find yourself needing to interact with websites and web services to retrieve data or perform certain actions. This is where sending HTTP requests comes into play. Understanding HTTP. HTTP, or Hypertext Transfer Protocol, is the underlying protocol used for communication on the World Wide Web. It allows clients, such as web browsers, to request resources from servers and receive responses in return. When you type a URL into your web browser and hit enter, your browser sends an HTTP request to the server hosting the website, and the server responds with the requested web page. The requests library. Python provides several libraries for sending HTTP requests, but one of the most popular and widely used is the requests library. It is a powerful and user-friendly library that simplifies the process of sending HTTP requests and handling responses. To use the requests library, you first need to install it. You can do this by running the following command in your terminal or command prompt. Pip install requests. Once you have installed the requests library, you can import it into your Python script using the following line of code. Import requests making GET requests. The most common type of HTTP request is the GET request, which is used to retrieve data from a server. With the requests library, making a GET request is as simple as calling the GET function and passing in the URL of the resource you want to retrieve. Here's an example. Import requests. Response equals requests.get. In the above example, we are making a GET request to the URL. The GET function returns a response object, which contains the server's response to our request. We can access the response's content using the content attribute. Import requests. Response equals requests.get print response, content. The content attribute returns the raw bytes of the response. If you want to retrieve the response as a string, you can use the text attribute instead. Import requests. Response equals requests.get print response, text. Handling response status codes. When making HTTP requests, it's important to handle the response status codes to determine if the request was successful or if there was an error. The requests library provides an easy way to access the status code of the response using the status_code attribute. Here's an example. Import requests. Response equals requests.get if response, status_code equals 200. Print request successful, else. Print request failed with status code, response, status_code. In the above example, we check if the status code of the response is 200, which indicates a successful request. If the status code is not 200, we print an error message along with the actual status code. Sending post requests. In addition to GET requests, you may also need to send post requests to a server. Post requests are used to submit data to be processed by the server. With the requests library, sending a post request is similar to making a GET request. You just need to call the post function and pass in the URL and the data you want to send. Here's an example. Import requests. Data equals username, John, password, secret, response equals requests, post data equals data. In the above example, we are sending a post request to the URL with the data, username, John, password, secret. The server will process the data and return a response. Conclusion. Sending HTTP requests is a fundamental skill for any Python programmer who wants to interact with websites and web services. The requests library provides a simple and intuitive way to send GET and POST requests, handle responses, and work with the data returned by the server. By mastering the art of sending HTTP requests, you can unlock a world of possibilities and harness the power of the internet in your Python programs. 10.3 Parsing HTML. HTML, Hypertext Markup Language, is the standard markup language used for creating web pages. It is the backbone of the internet and is used to structure the content and layout of a web page. When it comes to web scraping, parsing HTML is an essential skill to extract specific data from web pages. In this section, we will explore how to parse HTML using Python. We will learn about different libraries and techniques that can be used to extract data from HTML documents. Beautiful Soup. One of the most popular libraries for parsing HTML in Python is Beautiful Soup. It provides a simple and intuitive way to navigate, search, and modify the HTML structure. Beautiful Soup can handle poorly formatted HTML and is widely used for web scraping tasks. To use Beautiful Soup, you first need to install it. You can install it using pip by running the following command. Pip install Beautiful Soup 4. Once installed, you can import the library in your Python script using the following line. From BS4 import Beautiful Soup. To parse an HTML document, you need to create a Beautiful Soup object by passing the HTML content and the parser type. Beautiful Soup supports different parser types, such as HTML, parser, LXML, and HTML5lib. Here's an example of parsing an HTML document using Beautiful Soup. HTML_doc equals less than HTML greater than less than head greater than less than title greater than sample HTML document less than title greater than head greater than less than body greater than less than h1 greater than welcome to Python primer less than h1 greater than p greater than this is a sample paragraph less than p greater than ul greater than less than li greater than item 1 less than li greater than li greater than item 2 less than li greater than li greater than item 3 less than li greater than ul greater than less than body greater than HTML greater than soup equals Beautiful Soup HTML_doc HTML parser. Once you have created the Beautiful Soup object, you can navigate and search the HTML structure using various methods and attributes provided by the library. For example, you can access the title of the HTML document using the title attribute. Title equals soup, title. Print title, text hash output, sample HTML document. You can also find specific elements using methods like find and find_all. The find method returns the first matching element, while the find_all method returns a list of all matching elements. Here's an example of finding all the paragraph elements in the HTML document. Paragraphs equals soup, find_all p, for p in paragraphs. Print page text XPath. XPath is a language used for navigating XML and HTML documents. It provides a way to select elements and attributes based on their location in the document. XPath is widely used in web scraping to extract data from HTML documents. Python provides the LXML library, which includes an XPath implementation. To use XPath in Python, you need to install the LXML library using pip. Pip install LXML. Once installed, you can import the library in your Python script using the following line. From LXML import etree. To parse an HTML document using XPath, you first need to create an element tree object by passing the HTML content. Here's an example of parsing an HTML document using XPath. HTML_doc equals less than HTML greater than head greater than less than title greater than sample HTML document less than title greater than head greater than less than body greater than less than h1 greater than welcome to Python primer less than h1 greater than p greater than this is a sample paragraph less than p greater than ul greater than less than li greater than item 1 less than li greater than li greater than item 2 less than li greater than li greater than item 3 less than li greater than ul greater than less than body greater than HTML greater than tree equals etree HTML_doc. Once you have created the element tree object, you can use XPath expressions to select elements from the HTML document. XPath expressions are written as strings and can be passed to the XPath method of the element tree object. Here's an example of selecting the title of the HTML document using XPath. Title equals tree. XPath title text print title 0 hash output sample HTML document. You can also select multiple elements using XPath. For example, to select all the paragraph elements in the HTML document, you can use the following XPath expression. Paragraphs equals tree. XPath p text for p in paragraphs. Print p. XPath provides a powerful way to navigate and extract data from HTML documents. It supports various operators and functions that can be used to filter and manipulate the selected elements. Conclusion. Parsing HTML is a crucial skill for web scraping and extracting data from web pages. In this section, we explored two popular libraries, Beautiful Soup and LXML, that can be used to parse HTML in Python. Beautiful Soup provides a simple and intuitive way to navigate and search the HTML structure, while LXML offers a powerful XPath implementation for selecting elements from HTML documents. By mastering the art of parsing HTML, you will be able to extract valuable data from websites and automate various tasks that involve web scraping. 10.4 Scraping dynamic websites. In the previous sections, we learned about the basics of web scraping and how to parse HTML content. However, many modern websites are not static and rely on dynamic content generated by JavaScript. This poses a challenge when it comes to web scraping, as traditional methods may not work effectively. In this section, we will explore techniques to scrape dynamic websites using Python. Understanding dynamic websites. Dynamic websites are built using technologies like JavaScript, which allows for interactive and real-time content updates. Unlike static websites, where the HTML content is pre-rendered on the server and sent to the client, dynamic websites generate HTML content on the client side using JavaScript. This means that the HTML structure and content may change dynamically based on user interactions or data fetched from external sources. When scraping dynamic websites, we need to consider how the dynamic content is loaded and rendered. In many cases, the initial HTML response from the server may not contain the complete content. Instead, it may include JavaScript code that fetches additional data from the server or modifies the existing HTML structure. To scrape such websites, we need to understand how the dynamic content is loaded and replicate the necessary requests and interactions. Using headless browsers. One approach to scraping dynamic websites is to use a headless browser. A headless browser is a web browser without a graphical user interface, which can be controlled programmatically. It allows us to execute JavaScript code and interact with the website just like a regular browser. Python provides several libraries that enable us to automate headless browsers, such as Selenium and Puppeteer. These libraries allow us to open a web page, execute JavaScript, and retrieve the updated HTML content. By using a headless browser, we can scrape dynamic websites that rely heavily on JavaScript. To use Selenium, we need to install the Selenium library in a WebDriver specific to the browser we want to automate. For example, if we want to use Chrome, we need to install the Chrome driver. Once installed, we can write Python code to control the browser and scrape the dynamic content. Here's an example of using Selenium to scrape a dynamic website. From Selenium import WebDriver. Hash create a new instance of the Chrome driver equals WebDriver, Chrome. Hash navigate to the website driver.get. Hash wait for the dynamic content to load driver, implicitly _wait 10. Hash extract the HTML content HTML_content equals driver, page _source. Hash close the browser driver, quit. In this example, we create a new instance of the Chrome driver and navigate to the desired website. We then wait for the dynamic content to load using the implicitly _wait method. Finally, we extract the HTML content using the page _source property and close the browser. Inspecting network requests. Another approach to scraping dynamic websites is to inspect the network requests made by the website and replicate them programmatically. Modern browsers provide developer tools that allow us to monitor network requests and analyze the data exchanged between the client and the server. To inspect network requests, we can open the developer tools in our browser, usually by right-clicking on the web page and selecting Inspect, or pressing Ctrl+Shift+I. In the Network tab, we can see all the requests made by the website, including AJAX requests and API calls. By analyzing the network requests, we can identify the URLs, headers, and parameters required to fetch the dynamic content. We can then replicate these requests using Python's requests library or any other HTTP client library. Here's an example of scraping a dynamic website by replicating network requests. Import requests. Hash send a GET request to fetch the initial HTML content response equals requests.get. Hash extract the necessary data from the response data equals response, JSON. Hash send additional requests to fetch dynamic content dynamic_response equals requests.get params equals id, data id. Hash extract the dynamic content from the response dynamic_data equals dynamic_response, JSON. In this example, we send a GET request to fetch the initial HTML content. We then extract the necessary data from the response, which may include information required for subsequent requests. Finally, we send additional requests to fetch the dynamic content, passing any required parameters, and extract the data from the response. Conclusion. Scraping dynamic websites requires additional techniques compared to scraping static websites. By using headless browsers or replicating network requests, we can overcome the challenges posed by dynamic content generated by JavaScript. Python provides libraries like Selenium and requests that enable us to automate browsers and interact with websites programmatically. With these tools, we can effectively scrape dynamic websites and extract the desired data for further analysis or processing. 11. GUI programming. 11.1 Introduction to GUI programming. Graphical User Interface (GUI) programming is an essential aspect of modern software development. It allows users to interact with applications through visual elements such as buttons, menus, and windows. Python provides several libraries and frameworks for GUI programming, making it a versatile language for creating user-friendly applications. In this section, we will explore the basics of GUI programming with Python. We will discuss the different libraries available, the fundamental concepts of GUI programming, and how to create simple graphical applications. GUI libraries in Python. Python offers several libraries for GUI programming, each with its own set of features and capabilities. Some of the popular libraries include Tkinter. Tkinter is the standard GUI library for Python and is included with most Python installations. It provides a simple and easy-to-use interface for creating GUI applications. Tkinter is based on the TK-GUI toolkit, which originated from the TCL programming language. PyQt. PyQt is a set of Python bindings for the Qt application framework. Qt is a powerful and widely used GUI toolkit that provides a comprehensive set of tools for creating cross-platform applications. PyQt allows developers to create professional-looking GUI applications with advanced features. WXPython. WXPython is another popular GUI library for Python, based on the WXWidgets C++ library. It provides a native look and feel on different platforms and supports a wide range of widgets and controls. WX-Python is known for its ease of use and flexibility. Kivy is an open-source Python library for developing multi-touch applications. It is designed to be cross-platform and supports various input methods, including touchscreens. Kivy uses OpenGL for rendering and provides a rich set of UI components. These are just a few examples of the GUI libraries available in Python. Depending on your requirements and preferences, you can choose the library that best suits your needs. Fundamental concepts of GUI programming. Before diving into GUI programming, it is essential to understand some fundamental concepts. Widgets. Widgets are the building blocks of GUI applications. They represent the various elements that users interact with, such as buttons, labels, text boxes, and menus. Each widget has its own properties and behaviors. Layouts. Layouts define how widgets are arranged within a window or a container. They determine the positioning and sizing of widgets. Common layout types include grid layout, box layout, and absolute positioning. Events. Events are actions or occurrences that happen within a GUI application, such as clicking a button or typing in a text box. Event handling is a crucial aspect of GUI programming, as it allows the application to respond to user interactions. Callbacks. Callbacks are functions that are executed in response to specific events. They define the behavior of the application when a particular event occurs. For example, a button click event may trigger a callback function that performs a specific action. Creating a simple GUI application. To illustrate the process of creating a GUI application, let's walk through a simple example using the tkinter library. Import tkinter as tk. Def button _ click. Label, config text equals, button clicked. Root equals tk. Root, title, simple GUI application. Label equals tk. Label root, text equals, hello, GUI. Label, pack. Button equals tk. Button, root, text equals, click me, command equals button _ click button, pack. Root, main loop. In this example, we first import the tkinter module and create a function button _ click that will be called when the button is clicked. Inside the function, we update the text of the label widget. Next, we create an instance of the tk class, which represents the main window of the application. We set the title of the window using the title method. Then, we create a label widget and a button widget using the label and button classes, respectively. We pass the root window as the parent for both widgets. The text parameter is used to set the initial text of the label and button. We use the pack method to add the widgets to the window. The pack method arranges the widgets in a vertical layout. Finally, we start the main event loop using the main loop method. This loop listens for events and updates the GUI accordingly. When you run this code, a window will appear with a label displaying, hello, GUI. And a button labeled, click me. Clicking the button will update the label text to, button clicked. This example demonstrates the basic structure of a GUI application and how to handle events using callbacks. In the next section, we will explore event handling in more detail and learn how to create more complex GUI applications. 11.2 Creating GUI applications. Graphical user interfaces (GUIs) are an essential part of modern software applications. They provide a visual way for users to interact with the program, making it more intuitive and user-friendly. In this section, we will explore how to create GUI applications using Python. Python offers several libraries for GUI development, including tkinter, pyqt, and wxPython. In this section, we will focus on tkinter, which is the standard GUI toolkit for Python. Tkinter Basics. Tkinter is a built-in Python library that provides a set of tools for creating GUI applications. It is based on the TK GUI toolkit, which originated in the TCL programming language. Tkinter provides a wide range of widgets, such as buttons, labels, text boxes, and menus, that can be used to build the user interface of an application. To start using tkinter, you need to import the library by adding the following line at the beginning of your Python script. Import tkinter as tk. Once imported, you can create a new tkinter window by creating an instance of the tk class. Window equals tk. This will create a new window with a title bar and a close button. You can customize the appearance of the window by setting its attributes, such as the title, size, and background color. Adding widgets. After creating the main window, you can add widgets to it. Tkinter provides a wide range of widgets that can be used to build the user interface. Some of the commonly used widgets include labels, used to display text or images. Buttons, used to trigger actions when clicked. Entry, used to accept user input. Text, used to display and edit multiline text. Check button, used to represent a binary choice. Radio button, used to represent a set of mutually exclusive choices. List box, used to display a list of items. Combo box, used to display a drop-down list of items. To add a widget to the window, you need to create an instance of the widget class and use the pack method to place it in the window. For example, to add a label to the window, you can use the following code. Label equals tk. label window, text equals, hello, world. Label, pack. This will create a label with the text, hello, world. And add it to the window. Handling events. GUI applications are event-driven, which means they respond to user actions, such as clicking a button or typing in a text box. Tkinter provides a mechanism for handling these events through event bindings. To handle an event, you need to define a callback function that will be called when the event occurs. The callback function takes an event object as a parameter, which contains information about the event. For example, to handle a button click event, you can define a callback function like this. Def button underscore click event. Print button clicked. Button equals TK. Button window, text equals, click me, button. Bind less than button minus 1 greater than, button underscore click button, pack. In this example, the button underscore click function is called when the button is clicked. It simply prints a message to the console. Layout management. Tkinter provides several layout managers that can be used to arrange widgets in the window. The most commonly used layout manager is the pack method, which automatically arranges the widgets in a vertical or horizontal layout. You can also use the grid method to create a grid-like layout, where widgets are placed in rows and columns. This allows for more precise control over the placement of widgets. Another layout manager is the place method, which allows you to specify the exact position and size of a widget using coordinates. This can be useful for creating custom layouts. Building a simple calculator. To demonstrate the use of Tkinter for GUI application development, let's build a simple calculator. The calculator will have buttons for numbers and operators, an entry field to display the result, and a button to calculate the result. First, create a new Tkinter window and set its title. Window equals TK. TK window. Title calculator. Next, create an entry field to display the result. Result equals TK. Entry window result, pack. Then, create buttons for numbers and operators. Buttons equals 7 inches, 8 inches, 9 inches, 4 inches, 5 inches, 6 inches, asterisk, 1 inch, 2 inches, 3 inches, 0 inches, equals, plus. For button underscore text in buttons. Button equals TK. Button window, text equals button underscore text button. Packed side equals, left. Finally, add event handlers for button clicks and implement the calculator logic. Def button underscore click event. Button underscore text equals event. Widget, see get text, if button underscore text equals, expression equals result dot get result. Delete 0, TK. End result, insert TK. End, eval expression else. Result, insert TK. End, button underscore text. For button in window, winfo underscore children. Button, bind less than button minus 1 greater than, button underscore click. This will create a simple calculator that can perform basic arithmetic operations. Conclusion. In this section, we explored how to create GUI applications using Tkinter, the standard GUI toolkit for Python. We learned how to create windows, add widgets, handle events, and manage layouts. With Tkinter, you can build interactive and user-friendly applications that enhance the user experience. 11.3 Event Handling. In GUI programming, event handling is a crucial aspect that allows us to respond to user interactions with our graphical user interface. Events can be triggered by various actions, such as clicking a button, typing in a text field, or moving the mouse. Python provides several libraries and frameworks that make event handling easy and efficient. Understanding events. Before diving into event handling in Python, it's important to understand the concept of events. An event is an action or occurrence that happens within a program, typically initiated by the user. Examples of events include clicking a button, pressing a key, or moving the mouse. In GUI programming, events are used to trigger specific actions or functions. For example, when a user clicks a button, an event is generated, and we can associate a function with that event to perform a specific task. This allows us to create interactive and responsive user interfaces. Event-driven programming. Event handling is a fundamental aspect of event-driven programming. In event-driven programming, the flow of the program is determined by events rather than a predefined sequence of instructions. The program waits for events to occur and then responds accordingly. Python provides several libraries and frameworks for event-driven programming, such as Tkinter, PyQt, and WXPython. These libraries offer a wide range of tools and functionalities to handle events effectively. Event handling in Tkinter. Tkinter is a popular GUI toolkit for Python that provides a simple and intuitive way to create graphical user interfaces. It also offers robust event handling capabilities. Let's take a look at how event handling works in Tkinter. To handle events in Tkinter, we need to follow a few steps. Define the event handler function. First, we need to define a function that will be called when the event occurs. This function will contain the code that needs to be executed in response to the event. Bind the event to the widget. Next, we need to bind the event to the widget that will trigger it. We can use the bind method to associate the event with the widget and the event handler function. Run the event loop. Finally, we need to start the event loop, which is responsible for detecting and handling events. The event loop continuously checks for events and calls the corresponding event handler functions when an event occurs. Here's an example that demonstrates event handling in tkinter. Import tkinter as tk. Def button underscore click. Print button clicked. Root equals tk. Button equals tk. Button root. Text equals click me. Command equals button underscore click button. Pack. Root. Main loop. In this example, we define a function button underscore click that will be called when the button is clicked. We bind the button underscore click function to the button using the command parameter. Finally, we start the event loop using the main loop method. When the button is clicked, the button underscore click function is called, and the message, button clicked, is printed to the console. Event handling in other GUI libraries. While tkinter is a popular choice for GUI programming in Python, there are other libraries and frameworks that offer event handling capabilities. PyQt and WXPython are two such libraries that provide powerful event handling mechanisms. In PyQt, event handling is similar to tkinter. We define event handler functions and bind them to the corresponding widgets using the connect method. The event loop is started using the exec underscore method. Import sys. From PyQt5, Qt widgets import Q application, Q main window, Q push button. Def button underscore click. Print button clicked. App equals Q application sys. Argv window equals Q main window. Button equals Q push button, click me, window button. Clicked, connect button underscore click. Window, show sys, exit app, exec underscore. In WXPython, event handling follows a similar pattern. We define event handler functions and bind them to the widgets using the bind method. The event loop is started using the main loop method. Import WX. Def button underscore click event. Print button clicked. App equals WX, app frame equals WX, frame none. Button equals WX, button frame, label equals, click me, button, bind WX, EVT underscore button underscore click. Frame, show app, main loop. Regardless of the GUI library or framework you choose, the basic principles of event handling remain the same. You define event handler functions, bind them to the appropriate widgets, and start the event loop to handle events. Conclusion. Event handling is a crucial aspect of GUI programming in Python. It allows us to create interactive and responsive user interfaces by responding to user actions. Python provides several libraries and frameworks, such as tkinter, PyQt, and WXPython, that make event handling easy and efficient. By understanding the concept of events and following the appropriate event handling techniques, you can create powerful and user-friendly GUI applications with Python. 11.4 GUI Best Practices. Graphical user interfaces (GUIs) play a crucial role in creating user-friendly and visually appealing applications. When developing GUI applications with Python, it is important to follow certain best practices to ensure that your application is efficient, maintainable, and provides a great user experience. In this section, we will discuss some of the key GUI best practices that you should keep in mind while developing Python GUI applications. 1. Consistency in design. Consistency is key when it comes to GUI design. It is important to maintain a consistent design throughout your application to provide a seamless user experience. This includes using consistent colors, fonts, and layouts across different screens or windows. By maintaining a consistent design, users will find it easier to navigate and understand your application. 2. Simplicity and clarity. Keeping your GUI design simple and clear is essential for a good user experience. Avoid cluttering the interface with too many elements or complex layouts. Instead, focus on presenting the most important information and functionality in a clear and intuitive manner. Use descriptive labels and icons to guide users and make it easy for them to understand the purpose of each element. 3. Responsiveness. A responsive GUI is crucial for a positive user experience. Ensure that your application responds quickly to user actions, such as button clicks or menu selections. Long delays or unresponsive interfaces can frustrate users and lead to a poor user experience. Use asynchronous programming techniques or separate threads to handle time-consuming tasks without blocking the main GUI thread. 4. Error handling and validation. Proper error handling and validation are essential for GUI applications. Validate user input to ensure that it meets the required format or constraints. Display clear error messages when input is invalid or when an error occurs during the execution of a task. By providing informative error messages, you can help users understand and resolve issues more easily. 5. Keyboard and mouse navigation. Consider users who prefer to navigate through your application using the keyboard instead of the mouse. Ensure that all important functionality can be accessed using keyboard shortcuts or hotkeys. Provide keyboard navigation options such as tabbing between input fields or using arrow keys to navigate through menus. This will improve accessibility and make your application more user-friendly. 6. Proper use of colors and visual elements. Colors and visual elements can greatly enhance the visual appeal of your GUI application. However, it is important to use them judiciously and with care. Choose a color scheme that is visually pleasing and easy on the eyes. Avoid using too many bright or contrasting colors that can strain the user's eyes. Use visual elements such as icons or images to convey information or guide users, but ensure that they are relevant and meaningful. 7. Documentation and help. Providing proper documentation and help resources is essential for users to understand and effectively use your GUI application. Include clear and concise documentation that explains the purpose and functionality of each feature. Provide tooltips or context-sensitive help to guide users when they hover over elements. Additionally, consider including a user manual or online help documentation to assist users in troubleshooting issues or learning how to use your application effectively. 8. Testing and quality assurance. Thoroughly test your GUI application to ensure that it functions as intended and provides a seamless user experience. Perform both functional and usability testing to identify and fix any bugs or issues. Test your application on different platforms and screen resolutions to ensure compatibility. Additionally, consider gathering user feedback and incorporating it into future updates to improve the overall quality of your application. 9. Performance optimization. Optimizing the performance of your GUI application is crucial for providing a smooth and responsive user experience. Identify and eliminate any bottlenecks or performance issues that may slow down your application. Use efficient algorithms and data structures, minimize unnecessary computations, and optimize resource usage. Regularly monitor and profile your application to identify areas for improvement and optimize accordingly. 10. Cross-platform compatibility. Consider designing your GUI application to be cross-platform compatible, allowing it to run on different operating systems without major modifications. Use platform-independent libraries and frameworks, such as Tkinter or PyQt, to ensure compatibility across different platforms. Test your application on different operating systems to ensure that it functions correctly and looks consistent. By following these GUI best practices, you can create Python GUI applications that are user-friendly, visually appealing, and efficient. Remember to prioritize the user experience and continuously seek feedback to improve your application over time. 12. Advanced topics. 12.1 Concurrency and multithreading. Concurrency and multithreading are advanced topics in Python that allow you to execute multiple tasks simultaneously. In this section, we will explore the concepts of concurrency and multithreading, and how they can be implemented in Python. Understanding concurrency. Concurrency refers to the ability of a program to execute multiple tasks concurrently. It allows different parts of a program to run independently and make progress simultaneously. Concurrency is particularly useful when dealing with tasks that can be executed independently and do not depend on each other's results. In Python, concurrency can be achieved through various techniques, such as multiprocessing, multithreading, and asynchronous programming. In this section, we will focus on multithreading. Multithreading in Python. Multithreading is a technique that allows multiple threads to run concurrently within a single process. A thread is a lightweight unit of execution that can perform tasks independently. By using multiple threads, you can achieve parallelism and improve the performance of your program. Python provides a built-in module called threading that allows you to create and manage threads. The threading module provides a high-level interface for working with threads and simplifies the process of creating and synchronizing threads. To create a thread in Python, you need to define a function that will be executed by the thread. This function is often referred to as a target function. You can then create an instance of the thread class from the threading module, passing the target function as an argument. Once the thread is created, you can start it by calling the start method. Here's an example that demonstrates how to create and start a thread in Python. Import threading. Def print _ numbers. For I in range 1, 6 print I. Hash create a thread. Thread equals threading. Thread target equals print _ numbers. Hash start the thread start. In this example, we define a function print _ numbers that prints the numbers from 1 to 5. We then create a thread using the thread class from the threading module, passing the print _ numbers function as the target. Finally, we start the thread by calling the start method. When you run this code, you will see the numbers 1 to 5 printed on the console. The thread runs concurrently with the main program, allowing both the main program and the thread to make progress simultaneously. Synchronization and thread safety. When working with multiple threads, it's important to ensure that they can safely access shared resources without causing conflicts or inconsistencies. This is known as synchronization. Python provides several synchronization primitives to help you synchronize access to shared resources. One commonly used primitive is the lock class from the threading module. A lock is used to ensure that only one thread can access a shared resource at a time. Here's an example that demonstrates how to use a lock to synchronize access to a shared resource. Import threading. Hash create a lock equals threading, lock. Hash shared resource counter equals 0. Def increment _ counter. Global counter with lock, counter plus equals 1. Hash create multiple threads equals for _ in range 10. Thread equals threading. Thread target equals increment _ counter threads, append thread. Hash start the threads for thread in threads. Thread, start. Hash wait for all threads to finish for thread in threads. Thread, join. Hash print the final value of the counter print counter, counter. In this example, we create a lock using the lock class from the threading module. We also define a shared resource counter that will be incremented by multiple threads. Inside the increment_counter function, we use the with statement to acquire the lock before incrementing the counter. This ensures that only one thread can access the counter at a time. By using a lock, we can prevent race conditions and ensure that the counter is incremented correctly. When you run this code, you will see that the final value of the counter is 10, indicating that all threads have successfully incremented the counter. Thread pool. Creating and managing multiple threads manually can be cumbersome, especially when dealing with a large number of tasks. Python provides a convenient way to manage threads using a thread pool. A thread pool is a collection of pre-initialized threads that can be reused to execute tasks. Instead of creating and starting individual threads, you can submit tasks to the thread pool, and it will automatically assign them to available threads. Python's concurrent futures module provides a high-level interface for working with thread pools. The thread pool executor class from this module allows you to create and manage a thread pool. Here's an example that demonstrates how to use a thread pool to execute tasks. Import concurrent futures. Def process_data data. Hash process the data print processing data. Hash create a thread pool. With concurrent futures, thread pool executor as executor. Hash submit tasks to the thread pool executor. Submit process_data, task 1 inch executor. Submit process_data, task 2 inches executor. Submit process_data, task 3 inches. In this example, we define a function process_data that simulates processing some data. We then create a thread pool using the thread pool executor class from the concurrent futures module. We submit 3 tasks to the thread pool using the submit method, passing the process_data function and the data to be processed as arguments. The thread pool automatically assigns the tasks to available threads and executes them concurrently. When you run this code, you will see that the tasks are processed concurrently, without the need to manually create and manage threads. Conclusion. Concurrency and multithreading are powerful techniques that allow you to improve the performance and responsiveness of your Python programs. By executing multiple tasks concurrently, you can make efficient use of system resources and achieve parallelism. In this section, we explored the concepts of concurrency and multithreading in Python. We learned how to create and start threads, synchronize access to shared resources, and use thread pools to manage tasks. With this knowledge, you can now leverage the power of concurrency and multithreading to build more efficient and responsive Python applications. 12.2 Networking and Socket Programming. Networking is a fundamental aspect of modern computing, allowing devices to communicate and share information with each other over a network. Python provides a powerful set of libraries and modules for networking and socket programming, making it easy to develop networked applications. Understanding networking. Before diving into socket programming, it's important to have a basic understanding of networking concepts. A network is a collection of devices connected together to share resources and exchange data. Each device on the network is assigned a unique identifier called an IP address, which allows other devices to locate and communicate with it. In networking, communication between devices is typically done using protocols. A protocol defines a set of rules and conventions that govern how data is transmitted and received. The most common protocol used on the Internet is the Transmission Control Protocol, Internet Protocol (TCP/IP). TCP/IP provides a reliable, connection-oriented communication between devices. Socket programming. Socket programming is a way to establish a network connection between two devices and exchange data. In Python, the socket module provides the necessary functions and classes to create and manage network sockets. A socket is an endpoint for sending or receiving data across a network. It can be thought of as a virtual communication channel between two devices. Sockets can be created for different types of communication, such as TCP or UDP. To create a socket in Python, you can use the socket function. Here's an example of creating a TCP socket. Import socket. Hash create a TCP socket. Sock equals socket, socket, AF_INET, sock_stream. In the example above, socket, AF_INET specifies the address family, which in this case is IPv4. Socket, sock_stream specifies the socket type, which is TCP. Once a socket is created, you can use various methods to establish a connection, send and receive data, and close the connection. Here are some common methods used in socket programming. Socket, bind, address binds the socket to a specific address and port. Socket, listen, backlog, listens for incoming connections. Socket, accept, accepts an incoming connection and returns a new socket object representing the connection. Socket, connect, address, connects the socket to a remote address. Socket, send data, sends data over the socket. Socket, recv, buffer_size, receives data from the socket. Socket, close, closes the socket. TCP socket example. Let's take a look at a simple example of using TCP sockets in Python. In this example, we'll create a server that listens for incoming connections and a client that connects to the server and sends a message. Server. Import socket. Hash create a TCP socket. Server_socket equals socket. Socket. AF_INET, socket, sock_stream. Hash bind the socket to a specific address and port server_address equals, localhost, 12,345, server_socket. Bind, server_address. Hash listen for incoming connections server_socket, listen, 1. Print server listening on format, *server_address. While true. Hash accept an incoming connection client_socket, client_address equals server_socket, accept print incoming connection from format, *client_address. Hash receive data from the client data equals client_socket, RECV 1024 print received, format data, decode. Hash send a response back to the client response equals, hello from the server. Client_socket, send response, encode. Hash close the connection client_socket, close. Client. Import socket. Hash create a TCP socket. Client_socket equals socket, socket, AF_INET, socket, sock_stream. Hash connect to the server_address equals, localhost, 12,345, client_socket. Connect server_address. Hash send a message to the server message equals, hello from the client. Client_socket, send message, encode. Hash receive a response from the server response equals client_socket, RECV 1024 print received, format response, decode. Hash close the connection client_socket, close. In this example, the server listens for incoming connections on localhost at port 12,345. When a client connects, the server receives a message from the client, sends a response back, and then closes the connection. UDP socket programming. In addition to TCP sockets, Python also supports UDP, User Datagram Protocol, sockets. UDP is a connectionless protocol that allows for faster communication but does not guarantee delivery or order of packets. To create a UDP socket, you can use the socket, sock_dgram socket type. Here's an example. Import socket. Hash create a UDP socket. Sock equals socket, socket, AF_INET, socket, sock_dgram. Once the socket is created, you can use the send to and receive from methods to send and receive data over the socket. Conclusion. Networking and socket programming are essential skills for developing networked applications. Python provides a comprehensive set of tools and libraries for working with sockets, making it easy to create robust and efficient networked applications. By understanding the basics of networking and socket programming, you can leverage the power of Python to build a wide range of networked applications. 12.3 Working with APIs. An API, or Application Programming Interface, is a set of rules and protocols that allows different software applications to communicate with each other. APIs are commonly used to retrieve data from external sources, such as web services or databases, and integrate it into your Python programs. In this section, we will explore how to work with APIs in Python. What is an API? An API acts as a bridge between different software applications, allowing them to interact and exchange data. It defines the methods and data formats that applications can use to communicate with each other. APIs can be used to access a wide range of services, including social media platforms, weather data, financial information, and much more. Types of APIs. There are several types of APIs, but the most common ones are Web APIs. These APIs are accessed over the internet using HTTP requests. They typically return data in formats like JSON or XML. Web APIs are widely used and provide access to a vast amount of data and services. Library APIs. These APIs are provided by software libraries and allow developers to use the functionality provided by the library in their own programs. Library APIs are typically used to extend the capabilities of a programming language or framework. Operating System APIs. These APIs provide access to the underlying operating system's functionality. They allow developers to interact with the file system, network, hardware devices, and other system resources. Making API requests. To interact with an API in Python, you need to make HTTP requests to the API's endpoints. An endpoint is a specific URL that represents a resource or a specific action that you want to perform. The most common types of HTTP requests are GET, retrieves data from the API. POST, sends data to the API to create a new resource. PUT, updates an existing resource. Delete, deletes a resource. Python provides several libraries for making HTTP requests, such as requests and URL. These libraries simplify the process of sending requests and handling responses. Handling API responses. When you make an API request, you will receive a response from the API server. The response typically includes a status code, headers, and the actual data you requested. The status code indicates whether the request was successful or encountered an error. Common status codes include 200, OK, the request was successful. 400, bad request, the request was malformed or invalid. 401, unauthorized, the request requires authentication. 404, not found, the requested resource was not found. 500, internal server error, the server encountered an error. To handle API responses in Python, you can use the response object returned by the HTTP request library. You can access the response's status code, headers, and content. Depending on the API's response format, you may need to parse the content using libraries like JSON or XML. Authenticating with APIs. Some APIs require authentication to access their resources. Authentication ensures that only authorized users can access the API's data. There are several authentication methods used by APIs, including API keys. An API key is a unique identifier that is used to authenticate requests. You typically include the API key as a parameter in your API requests. OAuth. OAuth is an open standard for authentication that allows users to grant access to their data without sharing their credentials. OAuth involves exchanging tokens between the client application and the API server. Basic authentication. Basic authentication involves sending the username and password as part of the request headers. This method is less secure than OAuth but is still used by some APIs. The authentication method required by an API will be specified in its documentation. Python libraries like requests provide built-in support for various authentication methods. Caching API responses. When working with APIs, it's common to make multiple requests for the same data. To improve performance and reduce the load on the API server, you can implement caching. Caching involves storing the API response locally and reusing it for subsequent requests. Python provides several caching libraries, such as requests cache, that can be used to implement caching in your API requests. These libraries allow you to specify the caching duration, cache storage location, and other caching options. API best practices. When working with APIs, it's important to follow best practices to ensure efficient and reliable integration. Some best practices include: read the API documentation. Before using an API, thoroughly read its documentation to understand its capabilities, limitations, and any specific requirements. Handle errors gracefully. APIs can encounter errors, such as rate limits or server issues. Make sure to handle these errors gracefully and provide appropriate feedback to the user. Implement rate limiting. Some APIs impose rate limits to prevent abuse. Make sure to respect these limits and implement rate limiting in your code if necessary. Keep API keys and credentials secure. API keys and credentials should be kept secure and not shared publicly. Store them in a secure location, such as environment variables or configuration files. Test and monitor your code. Regularly test your code to ensure it works correctly with the API. Monitor the API's performance and be prepared to adapt your code if the API changes. Working with APIs in Python opens up a world of possibilities for integrating external data and services into your applications. By understanding how to make API requests, handle responses, and authenticate with APIs, you can leverage the power of APIs to enhance your Python programs. 12.4 Testing and debugging. Testing and debugging are essential skills for any programmer. They help ensure that your code works as expected and allow you to identify and fix any errors or issues that may arise. In this section, we will explore various techniques and tools available in Python for testing and debugging your code. 12.4.1 Testing. Testing is the process of verifying that your code functions correctly and produces the expected results. It involves writing test cases that cover different scenarios and input values to ensure that your code behaves as intended. Python provides several frameworks and libraries for writing and running tests. Unit testing. Unit testing is a popular testing approach where individual units or components of your code are tested in isolation. The goal is to verify that each unit functions correctly on its own. Python's built-in unit test module provides a framework for writing and running unit tests. To write a unit test, you create a test class that inherits from the unit test case class. Each test method within the class represents a specific test case. You can use various assertion methods provided by the test case class to check if the actual output matches the expected output. Import unit test. Def add _ numbers a, b. Return a plus b. Class test add numbers unit test case. Def test _ add _ numbers self result equals add _ numbers 2, 3 self assert equal result 5. If _ name _ main __. Unit test main. In the above example, we define a function add _ numbers that adds two numbers. We then create a test class test add numbers that inherits from unit test case and define a test method test _ add _ numbers. Inside the test method, we call the add _ numbers function and use the assert equal method to check if the result is equal to the expected value. To run the unit tests, we use the unit Main function, which discovers all the test cases defined in the file and runs them. Integration testing. Integration testing involves testing the interaction between different components or modules of your code. It ensures that these components work together correctly. Python provides several libraries, such as Pytest and Nose, that make integration testing easier. These libraries allow you to define test cases using simple and expressive syntax. They also provide features like fixtures, which help set up and tear down test environments, and test discovery, which automatically discovers and runs test cases. Import Pytest. Def multiply underscore numbers a, b. Return a asterisk b. Def test underscore multiply underscore numbers. Result equals multiply underscore numbers 2, 3 assert result equals 6. In the above example, we use the Pytest library to define a test function test underscore multiply underscore numbers. Inside the function, we call the multiply underscore numbers function and use the assert statement to check if the result is equal to the expected value. To run the integration tests, we can simply execute the test file using the Pytest command. 12.4.2 Debugging. Debugging is the process of identifying and fixing errors or issues in your code. It involves analyzing the code's behavior, identifying the cause of the problem, and making the necessary changes to resolve it. Python provides several tools and techniques for debugging your code. Print statements. One of the simplest and most effective ways to debug your code is by using print statements. By strategically placing print statements at different points in your code, you can track the flow of execution and inspect the values of variables at specific points. Def divide underscore numbers a, b. Print f, dividing a by b, result equals a, b. Print f, the result is result, return result. Divide underscore numbers 10, 2. In the above example, we use print statements to display the values of a, b, and result at different stages of the divide underscore numbers function. This allows us to see the values and verify if they are as expected. Debugging tools. Python provides several debugging tools that can help you identify and fix errors more efficiently. One such tool is the PDB module, which provides a debugger for Python programs. It allows you to set breakpoints, step through code, and inspect variables at runtime. To use the PDB debugger, you can import the module and call the pdb.set_trace function at the point where you want to start debugging. Import PDB. Def divide underscore numbers a, b. Result equals a, b. pdb.set_trace return result. Divide underscore numbers 10, 0. In the above example, we import the PDB module and call the pdb.set_trace function after calculating the result. This will pause the execution of the program and start the debugger. From there, you can use various commands to step through the code, inspect variables, and identify the cause of the error. IDE debugging. Integrated development environments IDEs like PyCharm, Visual Studio Code, and PyDev provide built-in debugging features that make it easier to debug your code. These features include breakpoints, stepping through code, variable inspection, and more. To use the debugging features of your IDE, you typically set breakpoints at specific lines of code where you want the program to pause. When the program reaches a breakpoint, it will pause, and you can inspect variables and step through the code to identify and fix errors. Conclusion. Testing and debugging are crucial aspects of the software development process. By writing tests and using debugging techniques, you can ensure that your code works correctly and fix any issues that may arise. Python provides a variety of tools and libraries to facilitate testing and debugging, making it easier to develop robust and error-free applications.